Hello, ladies and gentlemen. I'm Xiaodong from Zhejiang University. I will chair the training workshop. According to schedules, we will start at the 5 p.m. Beijing times. Now we are waiting for the other persons from the WTRT culture of in New York, in United States. So we co-chair this training workshop. And also, I'm very honored to hold this workshop for all of you from the North Africa, from Morocco, from Egypt, and Tunisia. And also, I'm very thankful from the Everbright, the leading the enterprise of wasted energy in China. So today and tomorrow, we will arrange the sixth presentation from our university and Everbright. We will bring some experiments and to all of you. I hope after this training workshop, we can know each other's and we can set up more close the relationship between among our university and all your countries and even bright. Especially, we hope to provide some technical and some business support for your countries for the future waste treatment. So after a few minutes, we will start. We are waiting for the Mr. Reda and some persons from WTRTs. So see you. We are waiting. Okay, ladies and gentlemen, just because Mr. Reda from WTRT in United States, New York, so the time is very early, is early morning. So we should waiting. We should be waiting for several minutes. Just consider their times is very early in the morning. Several minutes. We will start. Okay. Ladies and gentlemen, just before our starting of this training workshop, maybe I can say some things for you. Wait for the Mr. Reda from WTRT, the co-organizer of this training workshop. Today, we will arrange the schedule is about at the beginning, we invite several very important persons from Everbright, from our colleagues of Zhejiang University, to give us a welcome speech. After the welcome speech, we arrange three presentations. One from our university, just by me. I will give your presentation about the waste characters and disposal status and China's waste management experiments. And the second is from Everbright, our co-organizers, and just mention Everbright is the top one, the leaders, the enterprise waste to energy in China. The second presentation is about the success story of waste energy technology in China, and also other developing countries. The third presentation is about the niche treatment technology, also from Everbright. After this, these three presentations, we will have a time free discussing and comments and the summary. So we will spend 3 or 4 hours for today the training schedules. So and then the same times tomorrow, we also arrange the 3 presentations. One from our university, Professor Chingxing Huang will introduce about municipal solid incineration technology. It's more special for technology. And the others is also from the Everbright. Is about about business models. It's very important, in my opinion. It's very useful for the Egypt and the Morocco's for the future based disposals considers is a very important business models. And another is the technology and application case of the solid native fuels SRF from Mr. Reda. And also we have enough time for discussing tomorrow. So this is the general arrangement our these two days, the training workshops. I hope Mr. Reda come here. Okay. Sorry, why? Maybe. Okay. Not for now. We are waiting for them. Yes. I found some voice for participant. It's okay for the participant to hear my voice. Is there any problems? Okay. I hope that this. I'm sorry, Mr. Reda. Just because the the training workshop much more coordinated work have been done by the Mr. Reda. Communicate with the Morocco and Egypt. So he is very important for our training workshop. I hope he will come. Maybe I call. Sorry, we should waiting for several minutes. I will call him. I'm sorry, I can contact Mr. Reda. Maybe I coordinate with the Eventbrite. So maybe we can start and waiting for the Reda as well. I can. Hello, Mr. Zhang Haifeng.
Yes. Yes. Yeah.
Maybe we can start first, and we are waiting for the Mr. Reda. Is okay?
Yes. Yes. Thank you. Thank you. Thank you, Professor Dr. Li. And ladies and gentlemen, it's a great pleasure to be part of this workshop. Please allow me, on behalf of Everbright Environment, to extend our warm congratulations on its opening and sincere welcome to our distinguished guests. Everbright Environment, as the world's largest waste-to-energy investor and operator, has a designed daily household waste processing capacity of more than 150,000 tons. With the service covering more than 120 million residents in China. We've also got a business presence in overseas markets, including Germany, Poland, Vietnam, and Mauritius. You might also find the corporate fact of our company in the chat room. As a organizer of this workshop, in the following days, my fellow colleagues shall share our wealth know-how and models and experience.
邵总，你声音静音了。
Oh, sorry. Are
you okay?
Okay. 那从头开始。好。Thank you, Professor Dr. Li, and ladies and gentlemen, it's a great pleasure to be part of this workshop. Please allow me, on behalf of Everbright Environment, to extend our warm congratulations on its opening and sincere welcome to our distinguished guests. Everbright Environment, as the world's largest waste-to-energy investor and operator, has designed a daily household waste processing capacity of more than 150,000 tons, with a service covering more than 120 million residents in China. We've also got a business presence in overseas markets, including Germany, Poland, Vietnam, and Mauritius. You might also find the corporate fact of our company in the chat room herewith. As an organizer of the workshop, in the following days, my fellow colleagues shall share our well-proven waste-to-energy know-how and overseas PPP model and experiences. We believe this is an appropriate moment, bringing us together to cooperate in achieving carbon reduction in your countries. The last but not least, we greatly appreciate the dedicated work of Zhejiang University, ICCWtE, and the Global WTERT Council. Thank you. And wish the workshop a great success. Thank you, Professor Dr. Li.
Okay, maybe we can invite Mr. Shao, the general of the manager of the Everbright Internationals. Mr. Shao, can you say something to us? iPhone. Okay. Next, maybe I'm ordered to invite Professor Xunxin Huang from our colleagues of energy engineering of Zhejiang University. He also he will give us the presentations. But now I invite him represent our colleague to say something to all of us. Professor Huang.
Hello.
Hello. Yeah, you're welcome.
Thank you for introduction and all participants, and good afternoon, and some country maybe good morning. And it's so glad to meet you on the net. And this training workshop has been supported by our university and our college for a long time, and especially for the developing countries. And waste-to-energy is very important, not only in developed, but also in many countries, especially like developing Africa countries. And from this training workshop, I believe we can learn a lot about how we can build a waste-to-energy plant and how we can convert the waste into the energy. And our university has been working on this area for a very long time, and we have got a lot of... Hello? We have got a lot honors and award from industry and also from our central government. And also we have a national lab and the national engineering lab, especially working on waste to energy and how we can improve the waste energy recovery efficiency and how we can control the pollutants like dioxin and heavy metals. And tomorrow I will give a brief introduction about incineration technology. And this technology are widely used. Some was developed from China domestically, and some technology was imported from the developed countries. And the successful story of this technology in China, and especially in many bigger cities, and I think this experience will provide you a lot know-how, and I think could help your countries and help you to how waste can be reused as materials. And our in our college, energy engineering college, we also have a lot of the professors working on these areas. And maybe in the near future, you would like to pursue a master or PhD degree. You also can come to our university, and we can support you. Our central government and also our local government provide scholarships for the students who want to learn this in energy engineering areas. And I think if you are interested in pursue a high degree, maybe you can contact with us. and we can you can carry out some research work on these areas. And I wish a big success of this workshop, especially for North America. And I hope all participants can learn a lot from this workshop. And I think we should keep in touch in the near future. And if you have chance, and please come to China and also come to our university, and you can take a look how waste can be cleanly transferred into energy and all other materials. And that's all. And we will meet tomorrow afternoon. And hope you can enjoy my presentation. And thank you very much, Professor Li. And that's all I want to talk.
Okay, thank you, Professor Huang. I hope you can open your videos. Maybe it's better. Okay, yeah, he's a very young.
Sorry, I'm still in my office, and we are.
Okay. I know you are working. We see tomorrow. So, ladies and gentlemen, very glad to hold this workshop. The warm welcome speech from Everbright and from Professor Chengxin Huang's to give us the short backgrounds of our training workshop. Actually, the training workshop, we cooperation with the Mr. Reda from the WTRT Council. We try to provide this training for the North Africa, especially for the Morocco and Egypt, to provide some experiments and some knowledge for the waste to energy to them. And I'm very glad to receive all of you participants much more than our consideration early. Now that I say more than 50 participants from the Morocco and Egypt to attend the training workshop. Very thanks. We try to provide more useful information and more experiments from our university and Everbright to you. And I hope after this workshop, we keep contact. This is our objective. And also from Everbright. Everbright is enterprise. We are the university. We from academy and Everbright from the enterprise. We cooperation to hope to provide some assistance and some potential cooperations in the future with you. We try to cooperation to deal with the waste problems in your countries and also for the world, for the globals. So Reda just send message to us. He tried to connect. I checked whether he is here. If not, maybe I can start my presentations. Maybe you know our schedules. I said earlier. Today we will arrange 3 presentations. The first is from our university. It's by me. Maybe I can share my presentations. Reda, you can check Reda here. Mr. Reda. Okay, Mr. Reda. Can you hear me?
Good morning. Good afternoon.
Okay. We are
Very good.
waiting for you. And before my presentations, maybe you can say some things. I'm sorry. It's too early for you. I see.
Yeah, it's early. Yeah, exactly. So,
very important for us. Maybe you say some things. Okay, you're welcome.
Well, thank you so much. Well, good afternoon, good evening to everyone. It is 4 a.m. here in DC. I'm currently in Washington, DC. So I'm very glad and, to welcome you everyone to this workshop, international workshop regarding the waste to energy for North Africa. These are, training, has been, organized by, the Zhejiang University, the International Consulting of Waste to Energy, and also the Earth Engineering Center of the University of Columbia, and which is we with our association, the WTRT, which is the acronym of the Waste to Energy Research and Technology Council. That's the main objective, is to bring together industries, government, and also academia to work all together to advance the sustainable development of waste management globally. So welcome. Today, these 2 days for training, you're gonna learn a lot regarding the experience of the China, how they could the success stories, how they succeed to phase out the landfill, and also to implement technologies of waste to energy, very competitive comparing to the landfill. And we hope from this training that you can learn, inspire, and also to collaborate all together to sharing experience, working on scientific cooperation and training, hopefully to accelerate the transformation and phase out the landfills in North Africa into technologies, into waste to energy technologies. And I'm very glad you guys, all of you join from Morocco, Tunisia, and Egypt. And so let's start. And I hope Professor Xiaodong will take care of this first day of moderation for this event. And also I'm gonna support him for today and tomorrow. Thank you so much.
Okay, thank you, Mr. Reda. Very thank you for your excellent work, and this is our got to the success, the results. Thank you for your contribution. According to the schedules, we can start our presentations. The first is me. I bring some experiments and some background and for the waste to energies in China. My topic is the municipal solid waste incineration and its application in China. My presentation will divide 4 parts. The first is about the municipal solid waste, MSW. We call it MSW. The generation and characters and disposal, the short introductions. And then the current situation of waste energies technologies. Where the information about the waste incineration and experiments application in China, past 3 decades in China, we got more useful experiments. But besides my presentation, and I believe the more experiments from Everbright will give you more details. My background, maybe I introduce myself. My background is the energy thermophysics. I graduated in Zhejiang University. I have more than 30 years in the waste to energies, and also I cooperation with our international internationals. And nowadays I fund and the chair of the international consulting committees. Our committees we do some voluntary works for consulting and for trainings for developing countries, especially for the waste energies. Later, I will show you the websites. I'm from our university, at Zhejiang University. Zhejiang University, the top 3, the university is comprehensive, more strong in engineering. And we have over 37 colleges. This is our, we have some energy experiments for the waste energies. And also I'm working in the Incineration Institute for Thermal Power Engineering of the College of the Energy Engineering. This is the, also the R&D is the best in China. And according to our backgrounds, I will say my presentations. The first part is about the waste disposals. These are the global problems. I know very little your backgrounds. My participant backgrounds from university and from the department and the minister of the governments. Also, we all know the waste problems. The waste problems have a much more serious environmental pollutants. So the challenge for us how to deal with the waste energies. For the waste, always we classify the waste, solid waste for the many cities, and also from agricultural, countryside, and industry and natures, for example, forest. But the much more important for us for the municipal waste. Municipal waste, we can definitions according to the difference of the countries and organizations. For example, according to the OECD and PAHO, Pan America's Health Organization, and IPCC, always we depletion the difference depletion of the waste, solid waste. I'm sorry, cancel for this. Okay. This is a little difference according to these deflations. For example, in China, the deflation of the waste, municipal waste, is the waste product in the daily life or the activity to provide for the daily life of the city, as well as waste ruled by the law and administrations, regulations of. This is for the city of the daily life. But for according to PAHO or OECD, they may be including some the switch start and some the here's some the difference the waste. So, but anyway, for the municipal waste is we are the much important for us. If you look at the total, the whole, a huge amount is about 1.9 billion tons per year. There's the every day is much amount of the waste the generation in the world. For example, for per day, about 4.38 million tons per day in the world. But very serious for us, the much higher, about 70% of the still the landfill or dump site. So this is the challenge for us. The generate, if you look at the generator per capita, according to the global world organization, the average per persons per day is always about 0.74 kilograms per day. It's relative to the developed areas. For the lower and upper or middle, the higher is always is the generate increase with the developed areas. This is the depletion of the waste. Maybe in my opinion, is maybe in Morocco and Asia, you have also there is same depletions. And besides we consider the depletion of the solid waste, that we consider the harm of some the pollutants of related to the solid waste. Always, just because though I will show you the later. If you have a lot proper, the solid will give us much more the pollutants to the environment and also right to the human health. Besides, we consider waste management. The waste generation always right to the collection rates, always right to the income levels. The low income levels always only collect about half of the waste in the cities, and much amount of waste still not connected. This is a very important point. And also the other is the waste. If you consider waste management, maybe we pay attention for the components of the waste. Components, the waste always we consider the food, the glass, metals, papers, and plastic, and rubber, and wood, or others. This is nearly the same, but the composition of the waste components may be different across income levels. We do analysis, and in developed countries or also in China, we have done much work for the waste components and compositions. If you want to do the waste management, maybe you have localized the waste components. And for the fundamental character of the waste, maybe you can find some data according to some handbook and some reference. You can find some physics characters for these components, for example, for rubbish, for the papers, for the wood, or others. This is for the physics characters, and also for some chemicals characters, especially for the heating values. If you are interested for the hair metals or others, for some element components, maybe you can find some reference or some handbook. But for your countries, we still need some research work for these characters. We should do some fundamental research for the characters, especially for the heating values, for some pollutants elements. So this is very important before you consider waste management. For waste management, there have several terminologies. The first is disposal, and recovery, and reuse. Disposal means the final disposal without utilization purpose. And recovery means all kinds of the utilization of the waste, including the energy recovery. Reuse means the use of the products and which have been removed from the service. And according to the EU, the hierarchies for the waste management, maybe you are familiar with these hierarchies: prevention and reductions, recycling, recovery, and disposals. This is a hierarchy. Also, also in China, so we follow these hierarchies. This is the final disposals. If you want to do the up levels, recovery or recycling or reduction of product, that means much the challenges for us, the cost and the technologies and mechanisms and management systems is much challenging for us. So that means always we pay attention for the easy to realize for the for every countries. Disposal and easy to realize and easy to recover in energy recovery in the developing country or in developed areas of the countries, especially for example, in China. We start to pay attention for recycling or reduction, but we adopt some best available technologies for disposal and energy recovery. This is a hierarchy for the waste management. So that means we should consider the best available technology for the every countries, developing countries and developed countries. This is a difference. Is it according your background of the countries? In general, we always, according to the experiments of the developing developed countries, and also according to China experiments as well, we always consider these three kinds of the technologies or three kinds of measures to deal with the waste: nanofield, compost, and incineration. Maybe in that understanding what is the nanofield easy to understand, it is the pictures. We provide the land to dispose of the waste. The nanofield should be the last pushing for the waste treatment. Nanofield, we minimize the environment and here's reduce the waste. They have some benefits. The low cost compared to other technologies, the low cost and also we can provide protect the environment, and also we can use for disused mine and quarries in the future. This is advantages. The most important for every areas for every country is low cost. So the exact maybe nanofields is a hygienist and is a low hygienist nanofields. If you use the poor nanofield, maybe much serious environmental the problems for leaching, for the collapse of the waste, very poor the landfill, and always we can say the landfills open side the fires. Exactly generates much higher the greenhouse and others organic pollutants, especially for the dioxin. Maybe you know the dioxin exactly is the most toxic organic pollutants in some extenders. So dioxin is very important we consider. And always the poor open side, the nanofields can generate much higher dioxins. This is the data from Japan. The report got some data from some developing areas, covers some developing areas. We can say the dioxin levels. This is all the data is from the soil, much from the landfill side data, much higher the backgrounds. So that means the poor landfill is much poorer and this is if you want to high levels, the challenge of landfill is much problems for us. And also the other compost, maybe you understand the compost in my backyard, and also not just can generate the phosphorus and also they can reduce and protect the environmental from. But the compost, except for the organic materials, is not available for the inorganic And also they for the not easy to the large capacities and always some pollutants for the soil. So it's not the best available. So we consider waste energy besides the landfill and compost waste energies. Exact the waste energy, we always consider pyrolysis and gasification and incineration. What means that now I consider the that what is incineration? Incineration is a reaction of the fuel with oxygen, producing the energy in the form of the heat or the night. Exactly with I'm sorry. Maybe there's some components of the waste or react with the oxygen to generate carbon oxide and some others some the gas, and to generate the energy and heat. This is incineration. And also maybe you can heard some concept of for the pyrolysis and the gasification. Always we pyrolyze this with the without areas to generate some combustible gas. And the gasification also to use the pressure air to generate the combustion gas to gas, only the gas to generate. But easy to commercial application nowadays, according to the China and also others developing areas, EU and Japan and United States. This is incineration is the commercial application more available for to treat the waste. This is the system incineration. The waste from here to the put and the feeding to the incineration to generate the heat and night to exchange the heat with the water and the water to generate electricity. And then the flue gas after the we call air pollutant control device, including the semi-dry and bacteria and carbon injection to absorb dioxin and hair matters and then emit from the stock. This is the incineration process. So according to the incineration process, we always use some principle to control the pollutants and generate much high efficient heat and electricity. Incineration, the most advantage is the reduce the worms, according to compared to the landfill and others, and also the save the much the amount the space. I'm sorry, according to the time, just limited the time. I will quickly some data, maybe for the reductions, the carbon oxides represent the efficiency. And also we consider the advantage of the incineration maybe have some disadvantage of the incineration. The very important is the cost. Exact the incineration, we need the high investment and also operation cost. For example, compared to the landfill and the compost. For numbers for the United States is United States the cost always the incineration cost. If you in waste use the incineration, maybe you need the 100 US dollars per tons, and always for investment, maybe you need about several times. I'm sorry, several sometimes thousands US dollars per ton for constructions of the waste incineration. That means incineration waste energy is always we adopt for some developed areas or developing countries. We need some economy to support, but according to China experiments, we reduce this cost. According to our experiments, we reduce the operation cost from the 100 US dollars to several tens US dollars. Maybe later the Everbright can bring to the more detailed information for this. That means in waste energies in China and also in other developed areas of developing countries, this is the available technologies and available. We compare to the landfill and compost, and we can call it one of the best municipal solid waste disposal technologies according to our experiments. And also, in my opinion, according to some developing countries, now they have some case the waste energy already. I hope the Everbright can bring the the case information for you. The second part of my presentation is about the current situation of the waste technologies. Maybe you know, if you look at the histories of the waste energies, we can always separate the 4 generations. The 4 generation is exactly related to some pollutant control, dust remove, the chemical cleans, and the recovery of energies and materials. And also, if you look at the details, technologies, you can say related to the incineration technology, and also related to the gas clean and the pollutant controls, and also automatic control systems. This is with the technologies. Maybe I will provide my presentation material. You can check the more details for these generations. Just mentioned earlier, I think I'm very sorry for. Although we have a much high amount of the municipal solid generation in the world, but only about 11% is waste energies, much higher is still dumping and landfills. So we should. Okay, why is this? Can see why? I find some. Okay. I continue my. So if you look at this is according to some statistical data. Nowadays, over 900 waste energy facilities in the world. Maybe over 1,000 if you count of the. Why do we have some? Okay, sorry. So if you look at we have more and more waste energy facility already have been operating in the world. So that means is the much available for considers the waste energy apply in the some developing areas or developing countries. So if you consider the technology, we consider amount 1,000 the waste energy facility. We can divide the technologies, main technologies. We can divide the stock rate and fluidized batters. I just showed stock race is just like that. Is the feed the waste, the burn in the stock race, and the bed on the grades, and use the mechanism transferred of the during waste during the combustion. So this is the stock race, and also in the stock race we can realize the organizations and provide the system and the dry level and the fresh level. That means we fresh waste through the dryer and polarized and then combustion here and burn out. This is the combustion process in the stock rise. Is the stock rate maybe according to the technologies they can available for the different areas and according to some manufacturers and some companies, they developed several kinds of technologies, stock rates. For example, modding and the babcock and steel mill, and also several kinds of the technology. Maybe later I will show you in China's. And the second is the fluidized batter. What is the fluidized batter at? Is that we if here we used some inner materials and burned with the areas to realize the fluidized like status, mix the particle and the waste and some just like that, the fluidized batter. And the different kinds of fluidized batter, and the Ibra in Japan maybe used that. Maybe in China we use the circulating fluidized batter and just like that. And also they are the same, the fluidized batter systems with the stock rise. These two technologies, they have some available the performance. If you compare to the stock rate and the fluidized batters, they have the difference, the performance. For stock rates more variable for the mixed materials, for fresh mass burns. For fluidized batter, always for particle, for the even materials, we need the pretreatment systems, but they have some difference for the combustion performance and pollutants emissions. We can compare to. Okay. Anyway, for much, if you consider the waste to energies, we can design much beautiful and much environmental friendly waste to energies. For example, in Austria and also in Japan or in China, also we have more and more advanced and more environmental friendly waste to energies. Use this technology to realize the waste to energies. Okay, my presentation. The third part is I will just to have some introduction for waste to energy in China. Maybe you know China is the most popular population in China, and also we have a large areas. But we have always in China we have the different divisions, the difference, the economy developed areas. Always they have a big difference areas. We have much developed areas. For example, here the southeast of China is much developed areas. the GDP of these areas is near the same the developing areas of the world. Maybe that's nearly the same some Europe countries, nearly the same the South Koreas or something just like that. But we have some developing areas. In my opinion, maybe nearly still the developing areas that very low developing GDP compared to the developed areas. So that means the waste treatment in China, they have some different situations. But now in developed areas in China, we have much more waste energy facilities nowadays. Okay. I just show you some data our the GDP. If you look at the GDP from the since 2007, 2010, 2021, very quickly. Exactly, maybe the second countries of the world, less than the United States, the total GDP, and also the municipal generation much higher. Relative, we have very close the link between economic growth and waste generation. Now we have about 207 million tons per year. So this also maybe the number one in the world. And also in China's nowadays, always we have harnessed the trade, and the waste energy already becomes the dominant measures. And about 70% of the waste are burned in through the waste energy in China, and about 146 million tons per year are already waste energy in China. And also is already the top one in the terms of the waste incineration capacity in the very early in 2005. Since 2015, so we are overtaken the United States, Japan, and Europe. You can say the very quickly since 2000 waste energy in China. So that is a short background. Exactly if you look at the histories of the waste energy in China, we have very poor. Except in China's, the start points of the waste energy is in the early 1990s. The first model waste energy plants in China in 1985 in Shenzhen. Maybe you know this is a more scientific. The cities in China also we call it the Silicon Valley in China is a Shenzhen city. It is in 1985. We constructed the first model incineration. Since that time, we developed our incineration technology and application, and then more and more facilitate waste energies. But here I want to say some words for the incineration. According to our experiments at the very beginning of that period in China, we can heard the more and more concept about waste energy. Just to show you the incineration, segment incineration, oxygen control, polarized incineration, polarized gasification incineration, much more concept of our of the incineration at that period. After our more detailed understanding of the incineration and more case and more facilitate operation in China, we can understand exact waste energy, exact the incineration represent and cover oxygen control, price, gasification, incineration, all the including the incineration. Exact incineration. That means waste energy in China, we considers incineration, including the oxygen control, price, incineration, others concepts. Exact the incineration in China, the waste energies, that means the more advanced incineration, that means waste energy. Also, there is saying I mentioned in China, you use the two kinds of the technology, stock rate and circulating fluids are better. Stock rates, the first waste energy facility is from Martin. Just to show you Martin the stock rates. Since then, in China, we import many kinds of foreign stock rates technology from the others developed countries, from Japan, from Germany, from Belgium, from France, from America, from Sweden. We input many kinds of stock rate, and then we adopt, we applied, and we developed our country's domestic stock rates. Okay, maybe you look at the time in 1988, Shenzhen, in 2004, Hangzhou, several countries. The Germany Martins, 2005, Japan Koka, 2005, Belgian Seegers is very important. The different stock rates, 2006. Detroit, Austrian companies, Verlons is also the very important technology we provide. So many kind the foreign technology we adopt, we applied in China, and then there are some the China's enterprise, Everbright. Here, Everbright, they developed their own domestic technology stock rates and apply in China. Nowadays, much higher percentage of the waste energy is used these stock rates technologies. Okay, and I show you some information for our technology development for. Maybe you can say some, this is the capacity of the 1 line of waste energy. And this is a steam parameter of the heating recovery facilities. You can say since 1988 to 2010, the capacity is much higher. And also we improve our parameter of the steam run. And also, from this time to now, we can say our incineration process in China, from incineration to good incineration, and then to nowadays we call the clean incineration and clean emission. This is a situation I will develop. The second, the technology is a circulating fluids better. Is developed. We consider the challenges of our municipal solid waste in China's the mixed and low heating values in 1998. Our university developing the technologies flies better. Okay, I'm sorry. Okay. This is our university, the price bed here, and the cyclone and the heating recovery facility, and to generate air control device. And also after since 1988 to nowadays, we have some waste energy circulating flash bed incineration technology in China. This is the capacity for per unit. 1 unit, the capacity is of the very early only 150. Nowadays, for 1 line, we can realize to deal with the 1,000 ton per days. I want to say is if you want to use the circulating flash bed, you should adopt the pre-treatment systems, just the waste crushers, and the special the air distribution, and also this is the pre-treatment systems to classify plastic and glass and metal and others. So this is very important for the good performance for flash bedders. Okay, we always use the mechanical biological treatment technology in China. So we use this technology to combine flash bedder. Okay. And also, Red to the incineration technology in China, we have we have the emission standards. The first emission regulation for our countries in 2001. In that times, we have a little higher emission limited, and then we revised our standards in 2015. We reduced our emission values especially for the dioxins from the 1 petagrams to the level 1 petagrams. They're the same EU standards. And also you can say that we have, according to the time, developed areas much complicate the device, the air air pollutant controls device for particles, for the ester gas, for active carbon, for back filters, and SMCR, SMCR plus SCR. And also we have much complicated the influence, the dissolve, and influence the nitrogens, and we use the bacterials and SCR and wheat scrubs, a much clean device adopted in the waste energies. This is our developing areas. Okay. Nowadays, according to our some status in the governments, in up to the August of this year, there are about 848 waste incineration plants in operation in China, and about 1,850 incinerators operation nowadays, and about nearly the 90% is stock rates, and about 9% of the circulating flash bedders. So this is some points, read points is you can say back to the earlier I mentioned, there's many facility is located at the developed areas, but in the north and the northwest of the China and the north China is still developed. We still use the landfill or other measures to deal with the waste. Okay, some pictures in China, more advanced and much very beautiful designs of the waste energy in China. Okay, and also we have already go abroad for some enterprise, for example, for Everbright, for some enterprise of the waste energy in China already. This is the one pictures of the Vietnam. They have the one pictures. I think maybe the Everbright will give you more information. So the finals, the incineration situation in China, we for regulation of policy is very important for the development of the waste energies in China. For the waste management system in China, we always devise several levels. The first is Congress and SEPA or Mr. EPA. And also we have Minister of Construction and Minister of the Commerce of the Waste, the charge of the in charge of the different directions. For the law, Congress the waste, and also we have the code and the standards and the policy. And for standards, we always divide for construction, for products, for emission and technology. Always very important for emission. The emission standard will guide for the standards for construction, for products, and for technologies. So this is for these regulation systems. Now I will just show you. I mentioned our standards in 2014. Maybe you can compare to our regulations, limited data, and the EU directive. And we always, they are saying the EU regulation in China. And in some developed areas, for example, in Shenzhen, much serious limited compared to the state regulations. That means much serious requirements for the waste energies emission in some developed areas in China. Okay, for this, the regulation and the policy in China, they have, we can divide the three process. Very early, we just pay for the some emission, and encourage some policies. The second is the much more encourage policy to the waste energies, and the third we also focus on the developing large waste incineration facility, and pay more attention for the pollutant emission control, and for example, for the maybe for the continue monitoring systems for every facilities 9. This is so I'm sorry, maybe just a limited time. I just quickly to say this. Very important in China, we still have encourage and national policy to encourage waste energy in the future. For example, by the end of the 2025, we will waste energies. We still have more and more waste energy facility will be constructions. Maybe, for example, planned about 500 new facility in China. Maybe in some areas. Especially in the loss and loss waste of areas, maybe I'm sorry, in China, is it correct? Chinese fact. This higher is loss and loss waste in China. Okay. Anyway, we still have more and more waste energy in China in the future. Okay. The last parts of my experiments, I want to share my experiments, my consideration according to according to the application of the China waste energies. So very important, the development of the waste, the step by step. So the waste development, that means we should, for the whole countries, maybe we can focus on the more developed areas. We have more demo if influence of the waste energies, just because the much advanced waste energies compared to the nanofuel and compose and other, the waste energies, the advantages, you should consider the demo. This is very important in China. In China also, we have constructing very early in the much higher developed areas, for example, in Shenzhen, in Shanghai, in Hangzhou, in much developed areas. We can demo, and to demo to the citizen, to more and more sectors to accept the waste energy. Exactly, we can share the benefits of the waste energy of these developed areas. This is very important. And also, I'm sorry. And the second is the very important the cooperation among the academy and the research and industry. Why we say that? Maybe for the university, always we are interested for the technologies. We are interested for the character of the waste. And for industry, maybe they are interested for the technology. They can input technology and they can apply their some advanced technology. But if they have a gap, they cannot uniform to cooperation. Always they have the much time, the waste of time, and cannot understand the waste and can't understand the technology more detail, more efficient. In China, always we have the poor experiments, and also we have some successful the stories. For example, in our university, our university developed our technology in 1995. And we spend many areas to develop the technology in the laboratory. But in 1998, we cooperation with one industry company. We demo the plants in 1998. Since then, we developed very quickly, and the process success, we can got the much more success, the experiments and results to improve our technology. This is our story. For Everbright, I think this also the success in the stories for cooperation with the university, and this is very important. And okay, and the third maybe very important for policy. This is the for governments. The waste to energies in China, why we are successful. In my opinion, the most important in China, we use the electricity price subside and waste disposal both to support the waste to energy in China at the very early. We can provide much higher electricity price side to support the waste energy to operate to deal with the waste. This is a very effective policy, and also we have some tax-free tax-free to support the waste energy in China. This is and also others, maybe the government for support some manufacturers for the technology development. They have some scientific funding to support us. So this is very important support from the government in China is the success experiments. Okay. Okay, and the fourth, in my opinion, is very important, especially for the very early stages. It's very important to make clear the responsibility for every sectors, from the government, for the enterprise, for the public, also from experts, from academia. The opinions from the very early, in China, we also face the challenges, the lot in my backyards, the opinions, from face the challenges against the waste energies. So this is at that the time from the academic opinions, the negative or positive opinion for the waste important from academia, from university, from the institutes is very important, and also from the government and from the public to demo, to have to show them the success, the stories, to guide them to more scientific understanding waste energy from the academic is very important in China. We have we have the sample experiments, and also we have some stories, success stories. But maybe, in my opinion, so you should face the situation in the future, in my opinion. Maybe this is very important. Make clear at the very beginning story, at the very beginning storage of the waste energy or the waste disposal. Responsibility, a clear responsibility is very important. Okay, the final is the balance, and in my opinion, it's easy to understand the balance. The sectors, the government, the public, and the enterprise, and especially for the enterprise. In China, at the very early, when one company or one enterprise constructed the waste energy facility, for this company always faced much challenges, much serious requirements from the public, from the enterprise, from the government, much serious requirements. So this is very important to balance what's the responsibility or the benefit from the government, from the public, and for the enterprise is also very important. So that means we consider the public concern, and also we should consider the enterprise concern as well. So this is very important. And anyway, for the finally, waste energies, I want to say, just because with energies we need the higher construction and a higher operation cost compared to the nanofield. So that means for the developed areas of the several countries, or for something, they can realize very best available technologies, best available methods to waste disposal. This is my experience and my suggestions. Okay, if you consider, this is my presentations, and also I just said earlier, I cooperation several professor and expert from industries to fund the international training consulting. International Consulting Committee of Waste Energies. The website is www.ICCWtE.org. We are guaranteed to provide some voluntary work or consulting work in the future. If you are interested, we can keep contact for the waste energies in the future. I'm from the university. I will provide some academic consulting and support for our participant the future work. And also, I believe that Everbright can provide some industry from industry areas. So that's all. This is my presentation. Thank you very much. So, Mr. Reda.
Thank you. Yeah, thank you so much, Professor Lee. It is very interesting to share the experience of the waste to energy technologies in China. And I will take out that, indeed, China today is exceeding in terms of the capacity of treatment, the US, Europe, and Japan combined. It is very massive, and there is even, as you can see on the map with the red dots, the ongoing construction of the waste energy, which is very massive. Well, thank you everyone for following and attending the presentation of Professor Lee. I just want to say that I received a lot of questions on the chat. Also, I want to add you that I speak Arabic. بإمكانكم طرح أسئلتكم عند نهاية المؤتمر. And I will assist you on that. If anybody needs any question or assistance, you can reach out to me. The second thing is, at the end of this conference training, we're gonna provide you all the materials and the recording of this training, and also, oh yeah, I still have a lot of questions, but I record all the questions. So at the end of today training, there will be a discussion, right? And we can raise all these questions. Okay. Thank you so much. So for the next panelist, I will introduce Professor Zhengning Guo. He is a specialist of Waste Incineration Research Institute at Everbright Environment. He will present you the success stories of waste to energy technologies in China and other developing countries. So, Professor Guo, the floor is yours.
iPhone. Guo总。
哎，我上线了。
Okay, so yeah, I just want to say that there will be simultaneous translation for English and also for French. So obviously, Professor Lee, it's working now.
Yeah, maybe. 郭总，你是讲中文是吗？
我这个收听，我就是在中文频道讲就行了吧？
Okay, Mr. Reda, I want to say, Mr. Gu will say in Chinese. We will have the French, English, the simulate interpretation. Is okay?
Very good.
Okay. Okay. Maybe you can say to our participant, everyone. Our gentleman Gu will say in Chinese. We will use the French to English, stimulate interpretation. So pay attention.
Okay. So yeah, thank you so much. So just to everyone, just to everyone, don't worry,
Chinese too.
Yeah.
Chinese too.
Sure. Yeah. So everyone, don't worry. So Professor Go will start, in Chinese. You can speak in Chinese, but we will receive the simultaneous translation from Chinese to French and Chinese to English. Okay, just pay attention to that.
对，好，那非常感谢北非的朋友们来参加这次培训。然后我是光大环境研究院的这个就是研发部门的郭振宁，已经在焚烧系统的研发的领域的话，已经差不多已经有10年了。所以今天由我来分享生活垃圾焚烧的一些知识。那首先我想请大家看一下我们光大环境的一个英文版的宣传片。
郭总，您需要将声音也共享一下。这边没有声音。
视频没有声音是吗？
您需要重新共享，然后在共享的页面的左下角有一个选择共享声音和视频流畅度。
先停止。
对，先停止共享，
然后点共享。点的过程中左下角。
As China Everbright
现在可以了吧？
可以了。
International Limited is a backbone enterprise of China Everbright Group Limited, listed on the main board of the Stock Exchange of Hong Kong Limited. Everbright Environment operates with higher efficiency and vitality with its identity as a foreign enterprise and demonstrates stronger responsibility and strength with its nature as a central state-owned enterprise. China Everbright Group is a large financial conglomerate with business presence across China and the world. It is at the forefront of China's reform for opening up to the outside world, and also a key pioneer throughout China's effort to develop financial holding groups. In 2018, China Everbright Group put forward the 433 strategic deployment, in which Everbright Environment has been positioned as the top deployment as to become a world-leading ecological and environmental company. In 2003, as China attached great importance to environmental protection, Everbright Environment forayed into the industry. Over the past 18 years, the company has been dedicated to creating better investment value and undertaking more social responsibility, and therefore, it has established a golden brand in the green world. Now Everbright Environment has become the largest environmental protection enterprise in China and a world-class environmental group. Since 2003, the compound annual growth rate of total assets reached 29%. CAGR of revenue was 44%. CAGR of profit attributable to shareholders of the company was 32%. The company has invested in more than 450 projects that command a total investment exceeding 140 billion RMB and are located in more than 200 cities, counties, and districts across over 20 provinces, autonomous regions, and municipalities in China. The company has also expanded its business to overseas markets such as Germany, Poland, and Vietnam, supporting the Greenbelt and Road development. Everbright Environment adheres to its original aspiration to and mission of being devoted to ecology and environment for a beautiful China by complying with the industry's best standards for its environmental protection projects to ensure safe production, green operation, and compliant emission. Everbright Environment was awarded twice the Luban Prize, the highest recognition in China's construction industry. It is the first environmental enterprise in China that opens its environmental protection facilities for public visits, and it also has the largest number of facilities open to the public. It has developed China's first fenceless, fully open project that is located within the residential communities and equipped with public amenities, which is now the living room of the city, benefiting the neighborhood. The same project was included in the compilation of most challenging projects since the 18th CPC National Congress, composed by the Organization Department of the Central Committee of the CPC, and also in the first batch of the primary contact points for the key projects of the Central Commission for guiding cultural and ethical progress. To date, the company's designed daily waste processing capacity reaches approximately 140,000 tons. Designed annual biomass material processing capacity exceeds 8 million tons. Designed annual hazardous waste processing capacity exceeds 2.8 million tons. Designed daily water treatment capacity exceeds 6.5 million cubic meters. Over the years, Everbright Environment has been leading the industry. With 3 listed companies and 8 business sectors, the company demonstrates clear competitive advantages and strong development momentum. Environmental Energy has become the world's largest waste-to-energy investor and operator, taking a leading position in terms of business scale, efficiency, and quality. Everbright Green Tech, listed in Hong Kong, is a first-class investor and operator in China, specializing in integrated biomass utilization, hazardous waste treatment, and environmental remediation. Everbright Water, dual-listed in Singapore and Hong Kong, is a first-class water environment management service provider in China. Equipment Manufacturing is a backbone environmental protection equipment R&D institute and manufacturing service provider in China. The self-developed 850-ton and 1,000-ton large household waste grate furnaces have filled the gap in the domestic market and received the Technological Advancement Award granted by the Ministry of Ecology and Environment of China. Eco Recycling is positioned to become the first-class investor and operator dedicated to waste sorting and resource recycling in China. It has developed the 5 points in one line process and business model for waste sorting. Greenergy upholds the development philosophy of healthy, energy-saving, and intelligent living, and focuses on the R&D and manufacturing of energy-saving lighting products, urban streetlight upgrading, and urban outdoor lighting projects. Everbright New Sodium Lamp, lighting the way home. Envirotech aims to shape the future through innovation and creation, leveraging on its 4-in-1 technological innovation and R&D layout. It attaches great attention to the industrial academic collaborations, targeting to become a world-class center dedicated to green technological innovation and technological conversion. Environmental Planning, positioned to become a first-class planning and design institute in China, provides support to the ecological and environmental management, zero waste cities, as well as action plans relating to carbon neutrality. As a leading player in the environmental protection industry, Everbright Environment participates in developing domestic and international industrial standards. Everbright Environment collaborated with Columbia University to develop global guidelines for waste-to-energy projects. It partnered with Zhejiang University to establish the National Engineering Lab of Waste Incineration Technology. The company collaborated with Qingdao University of Technology to jointly launch an Environmental Technology Research Institute and a Dioxin Analysis and Detection Center. It also established China Everbright Green Technology Innovation Institute in Hong Kong. Everbright Environment has received numerous accolades due to its outstanding contributions and achievements. The second Ecological Civilization Award, a constituent stock of Dow Jones Sustainable Development Indices, a constituent stock of FTSE4 Good Index Outstanding Enterprise Award in response to climate change. Most honored company in Asia, one of the top 10 firms with highest corporate governance index scores in Hong Kong. Mr. Wang Tianyi, chairman of the board of the company, was named as a 2018-2019 Green China Person of the Year, in addition to Asia's Best CEO for 3 consecutive years. One shall set sail in the wind to take advantage and ride the rolling waves to stay ahead. Everbright Environment will firmly adhere to its aspiration and mission, as well as fulfill its responsibility. It will carry out the 3587 development strategy, which includes focusing on 3 major business areas, enhancing 5 major capabilities, cultivating 8 business sectors, and solidifying 7 aspects of safeguards. The company will continue to promote innovation-driven transformation and high-quality development, striving to become a world-leading ecological environment group. It will contribute Everbright's effort to the comprehensive transformation of economic and social development into a green model. Everbright Environment, devoted to ecology and environment for a beautiful China.
好了，好，下面的话，我就是正式展开我这次培训的内容。一下把它最大化。
Je vais agrandir la présentation. Voilà. Donc, la technique de traitement des déchets domestiques et son développement. D'abord, donc notre société est une société clé du groupe, est une société
外资3重身份，2022年上半年营收约214亿港币，总资产2000亿港币。光大环境是中国首个一站式全方位的综合环境处理服务商。光大环境目前有5个板块，分别是环保能源、环保水务、绿色环保、装备制造和研究院。分别处置业务的话，从水、生活垃圾、生物质、危险废弃物等等。装备制造是负责给这些我们的项目提供焚烧或者是垃圾处理、部分处理的一些装备，而我们研究院是为整个光大环境集团提供技术服务。光大环境，稍等一下啊。光大环境是中国最大的垃圾发电投资运营商。截止2022年6月，已有540个垃圾环保项目，累计投资超过1540亿元，落实垃圾发电项目超过170个，设计处理生活垃圾15万吨每天。目前我们光大环境主导的产品与技术包括我们自主研发的一个焚烧炉，还有德国的马丁炉、生物质往复直燃炉排、危险废弃物逆流回转窑、烟气净化、渗滤月处理等离子，还有配套的相关的自动控制系统。我们光大目前的典型的应用我们技术的项目有越南秦居生活垃圾发电厂，这个项目是2018年11月份投运的，还有镇江生活垃圾发电厂，1期的话是2011年8月份投运的，2期是2015年5月份投运。宿迁生活垃圾发电厂1期是2011年投运，2期是2017年投运。这上说的是2个项目是目前光大比较早的一个投资项目。后面的话是苏州生活垃圾发电厂，它有3期，分别在2006年、2009年、2013年投运。目前苏州4期在建的这个项目是准备是在2018到2019年投运。这是宁波生活垃圾发电厂，这是南京生活垃圾发电厂，这是吴江生活垃圾发电厂，这是我们光大目前烟气排放标准最严格的一个垃圾发电厂，就是杭州生活垃圾发电厂。第二个下面就讲一下具体的一些垃圾焚烧的相关知识。第一个是生活垃圾的概念，人们在生活中日常生活服务中产生的固体废弃物称之为生活垃圾，不同于工业垃圾、建筑垃圾、医疗废弃物和危险废弃物。生活垃圾的分类分类的话，按照不同的类型可以这样分，比如说有机物包括厨余、纸类、纤维、布、木竹、塑料等，这些东西也是可以燃烧的。还有无机物，包括玻璃、金属、灰渣、砖瓦、陶瓷等，这是不可以燃烧的。 那还有一个就是水分。生活垃圾按照不同的按照不同的这个成分又有不同的热值。比如说下面这个表就是塑料的话，它的热值可能到7800，而这个绿色，然后这个食品垃圾，还有一些餐厨垃圾的话，它热值就会更加低一点。所以我们生活垃圾焚烧炉的话是处置这些所有这种不同垃圾，就是这种所有垃圾进行混合之后的一种垃圾。影响生活垃圾的因素是人们的一个生活的水平，还有当地的一个人口。大城市的生活垃圾的日产量大概是平均是每人1到2000克每公斤。在我们的国内也是一样的，但是可能在一些比如说更加发达的一些地区，可能要更高一些。中国城市垃圾的含水率一般是40%到60%，有比较明显的季节特征，也就是降水量越大的话，它的含水率就会越高。生活垃圾的渗滤率，生活垃圾的有机成分中有水分，在收运、运输、处置过程中，发生物理化学生物反应渗出来的液体，称之为渗滤液。垃圾渗滤液是高污染、高浓度多病原体的一个有机固废，是垃圾处置的一个2次污染源之一。生活垃圾的化学特性的话，包括它的元素、挥发分、热值等等。这是第一个表，就是典型的一个垃圾的一个组分。第二个表是它的这个垃圾的这个工业成分，就是包含了这个固定碳、挥发分、水分、灰分等等。第三个表是它的元素分析。那这些参数是我们设计一个垃圾焚烧厂的一个前提，因为我们要知道这个垃圾厂它的设计热值、它的物料成分是什么，然后我们才会针对这些针对性的这种垃圾特性来进行工程化的设计。首先讲垃圾热值。垃圾热值是垃圾完全燃烧释放的热量。垃圾热值有2种，第一个是高位热值和低位热值。我们通常说的这个垃圾焚烧厂的设计热值都是指的低位热值。二者的差异在于水分蒸发的潜热是否被放出。低位热值的话有很多的推导公式，就是下面有几个推导公式，基本推导的值都不会相差很多。那么通过不同的这个元素成分，可以计算出该成分下不同的垃圾热值。就是垃圾热值的话，也是可以通过一个三角图形的方法进行计算的。不过这种方法的话误差较大，作为一个粗略估算。影响垃圾热值的因素有很多，比如说灰分的影响，每减少1%的灰分，垃圾热值可以增加1%。比如说水分的影响，那含水率降低1%，那么垃圾的热值会增加150到165千焦每千克。垃圾的这个热值，包括除了上面说的这个低位、高位之外，还有这个原生垃圾和入场垃圾。原生垃圾是这个垃圾进入厂内的时候它的热值，入炉垃圾是垃圾进入厂内之后，在我的垃圾仓存储5到7天之后，投入我的焚烧炉系统内的热值。它主要的差异就是在含水量，因为在我们的垃圾仓内，垃圾会经过5到10天的堆放，它会产生一个中温发酵。那么中温发酵的过程中，会把水分给滤出，那进入焚烧炉内的这个水分就会大大降低。目前生活垃圾的处置方式有填埋、堆肥和焚烧。生活垃圾焚烧是我们比较推荐的一个处置方式，它具备减量化、无害化、资源化3个特点。填埋目前来说还是填埋垃圾，生活垃圾填埋目前来说还是成本还是一个比较广泛的一个技术。但是它的这个选址条件目前看比较困难，因为目前来说它的占地面积特别大，然后它的这个维护它工作量也非常大。这是生活垃圾填埋场配备的一个沼气发电系统。堆肥的话，它也是存在的一个成本高、工艺复杂、堆肥效率低的一个特点。所以我们综合看来的话，就是垃圾焚烧还是一个最终的处置方式。生活垃圾处置方式的话，一个最重要的就是我们要确定生活垃圾的一个热值，因为不同的热值的话，我选择的这个炉型，还有我们的锅炉的容量可能都不一样。 我们设计热值一般定在这个会比当前的这个目前测出来的生活垃圾热值要高。那么刚开始设计的时候，可能会适当的超负荷运行来满足我的额定工况。那么到了设计值之后的话，为额定处理量，其他的符合也不超负荷了，也是在额定符合范围。所以我们垃圾焚烧炉设计的时候，需要具备一定的超负荷量和超负荷能力。在我们国内，我们的“12-5”规划，我们的垃圾焚烧占比的话是占31%，但是我们在我们的“13-5”规划中，就是在2022年的时候，我们的这个垃圾焚烧处理量已经大于50%了。生活垃圾燃烧方式可以分为就是不同的技术的话，可以分为机械炉排炉、硫化床、回转窑和等离子炉4种。其中炉排炉的话，还可以分为顺推炉排炉、逆推炉排炉和滚筒炉排炉。顺推炉排炉顾名思义，它的这个垃圾的这个运动，它的这个它的燃烧的这个方向和我炉排的方向是相同的，我们称之为顺推炉排炉。逆推炉排炉的话，主要以德国马丁炉为代表，它的垃圾的运动方向和我炉排的运动方向是相反的，所以称为逆推炉排炉。滚筒式炉排炉的话，是将垃圾在燃烧的时候，将垃圾堆放，就是垃圾会在这个滚筒上进行一个滚动。那么这种技术的话，相对来说是占比最小的。生活垃圾在焚烧炉上燃烧是一个非常复杂的过程，它包括了就是垃圾进入焚烧炉之后，要经过加热升温、水分蒸发、挥发分析出、固定碳的一个燃烧以及排插等过程。在这过程中，我们的一次风是从下部往上进行一个向下进行一个进风，二次风是从炉膛的喉口进行进风，来保证焚烧炉的可燃物能够完全的燃尽。那为了实现焚烧炉的稳定运行的话，我们要多投入一些空气，也就是有一个过量空气系数的一个概念，就是我实际需要，比如说是1立方的这个空气，那么实际的时候我们可能会多投入1.6或者1.7的这个空气量，来保证它能够完全的一个燃烧。一次风焚烧炉的这个配风系统包含了一次风、二次风、炉墙冷却风等。一次风的话是从炉排的下部进风，它是不仅它给焚烧炉提供了一个助燃风之外，它还给我们的焚烧的设备炉排提供了一个冷却的一个作用，防止炉排过热变形。二次风的话是从炉膛的上方进行吹入，来进行就是我们垃圾产生的烟气给它一个充分的扰动，让垃圾产生的这个可燃烟气也能充分的燃烧。炉墙冷却风的话，它是给炉墙进行一个冷却，然后防止炉渣在炉膛上的一个结焦。生活垃圾发电系统，当前我们也是做了一些就是垃圾电厂选址的一些研究，就是哥伦比亚大学的协会也是调研过这方面的数据。实际上，其实大多数的生活垃圾电厂离市中心的距离其实都非常的近。生活垃圾的这个处理系统的话，大致分为以下几个系统。第一个就是垃圾进场后会进入一个前处理系统，然后会进入一个垃圾焚烧系统，然后再经过余热利用系统，最终进入到烟气净化系统，进行一个对，然后它在这个处理过程中会产生渗沥液、炉渣和飞灰。这是一个典型的一个垃圾，我们国内的一个超低排放的一个垃圾焚烧系统的一个流程图。那就是生活垃圾从我们的垃圾卸料坑进入一个垃圾卸料大厅，进入我们的卸料坑。那么卸料坑它会进行垃圾会进行一个5到7天的停留，然后产生的渗沥液就进入到我们的渗沥液处理系统。那么然后我们的这个垃圾再通过这个抓斗进入到这个焚烧炉的这个系统进行焚烧。那么这个焚烧系统的话，就是我们的垃圾焚烧系统。那焚烧出来的这个烟气经过换热之后产生蒸汽，那么会进入到一个汽轮机和一个发电机组里面去进行一个发电。那么这块那就是我们的一个余热利用系统。 那么同时，垃圾产生的这个烟气经过锅炉冷却之后，再进入到我们的后端的这个烟气净化系统里面进行一个处置，那么可以达到一个安全生产、完全燃烧、达标排放的目的。生活垃圾前端分拣系统，生活垃圾前端分拣系统，如果是想把生活垃圾里面有用的物料提取出来的话，是一个非常繁杂的过程。这个主要的话就是经过一个破碎，然后一个干化，然后经过滚筒筛、除铁器等等一系列的这个分选设备，将垃圾中的有色金属、塑料、纸类进行一个提纯，然后剩余的这些物质还是要进入到垃圾焚烧电厂进行焚烧。生活垃圾分拣系统可以增加资源的这个利用效率，但是目前成本较高，尚未在我国进行规模化应用。经过破碎、干化、机械粗分之后，进行智能光电分选，可以提高垃圾分选的一个纯度。这个是一个进料系统。进料系统的话是垃圾进场之后进入一个地秤，然后再进入一个垃圾卸料平台，就是这个平台，然后再进入垃圾仓。然后垃圾仓的上部会有一个1/4封的一个抽风口，进行一个垃圾仓的负压维护。那么经过5到7天的停留之后，那么垃圾抓斗再将垃圾送入焚烧系统。焚烧系统的话相对比较复杂，但是的话就是它最核心的一个部门就是我们的一个焚烧炉排，这个我们后面再介绍。垃圾余热系统的话是将垃圾燃烧之后产生的这个烟气和水蒸气跟我们的这个供质进行一个换热，那么产生的水蒸气进入到汽轮机里进行发电。那么在我国的话，垃圾发电占的这个总效率大概在整个电厂的总效率中占2/3。如果将生活垃圾的这个发电的话能够供热的话，那么能够进一步的提升垃圾电厂的一个经济效益。生活垃圾的就是烟气净化系统的话，如果是要满足我们典型的欧盟2010排放标准的话，需要用到 SNCR 半干法、干法、活性炭和布袋除尘器。那么后面的话会进一步介绍这个烟气净化系统的设计。垃圾焚烧系统的这个渗滤液产生之后，也要经过一个很长的流程。首先要经过调节池，然后经过厌氧，然后再经过一个 MBR 生化反应的一个工艺，然后产生的这个污泥的话是可以返回到我的焚烧炉进行焚烧。那么经过这个MBR 生化系统出来的水的话，经过化学软化UTF、RO、DT、RO 等处置工艺的话，它的这个水是可以进行一个回用的，也就是可以作为我这个就是我的冷却塔的一个冷却水。光大自主研发焚烧炉，我们光大自主研发焚烧炉的话，已经形成了一个系列化产品，规模从300到1000吨不等。我们的这个750吨的话，也是填补了我们国内的一个大型炉的一个空白。1000吨的话，目前已经在吴江建设，目前已经投运。这是我们焚烧炉的一个照片，这是750吨的一个焚烧炉，这是850吨的焚烧炉，这个是1000吨的焚烧炉。这个图片就是我们1000吨的焚烧炉在现场吊装的一个图片。然后1000吨焚烧炉非常的宽嘛，所以我们当时设计的时候也是做了一个非常跟它一个配套的一个吊举，来保证现场的一个安全的一个安装。焚烧炉系统的话，一般来说是从我们的焚烧炉的这个料斗开始，一直算到我们捞渣机的这个出口，这边所有的这个部分都算我们的生活垃圾焚烧炉。我们的焚烧炉的话，一般含有5个标准单元。前2个单元是用于干燥，中间2个单元是用于焚烧，最后1个单元是燃尽段，可以进行一个保证生活垃圾的一个充分燃尽。我们焚烧炉的布置方式是一个横向布置方式，而其他的这种大型炉排一般是采用纵向。横向布置方式的话，它的优点就是它的这个安装比较方便，然后它的这个液压缸也方便现场的一个维护。这是我们中间这个图就是我们焚烧炉吊装的一个图片。一些其他的技术的话，一般是采用一个纵列的一个布置方式。 我们焚烧炉的给料炉排，给料炉排就是专门将生活垃圾把它推入焚烧炉排的一个设备。然后我们也经过一个优化，来保证焚烧炉我们这个给料炉不会在运行中卡塞。然后我们的给料炉也调节非常的灵活，能够防止炉膛的就是可以防止这个燃烧在我们炉内进料不均匀造成的一个偏烧。我们的关键的这个机械结构也是经过一个优化，来保证我们的焚烧炉的使用寿命。我们焚烧炉的这个所有的机械结构是经过一个就是经过力学校核，包括它的热应力、热变形、热膨胀，都是在10倍载荷300度以下的这个情况下进行校核，来保证焚烧炉的安全可靠运行。这是我们的一些计算数据。然后我们焚烧炉就是设计完之后的话，我们也是要对这个焚烧炉进行一个验证，通过一个加载重物的方式，在焚烧炉上进行一个长期运行，然后来保证我的这个来验证我们的这个焚烧炉排是安全可靠的。当然我们的这个推料系统也是经过一个详细的计算，这是一个我们的一个计算过程，这是我们一个选型的一个计算。我们焚烧炉的话它是一个热机，所以要考虑一个热膨胀的一个问题，所以我们在焚烧炉的柱脚下面设计了一个自由膨胀的机构，能够让焚烧炉向两侧膨胀18毫米左右。目前这个机构已经在很多项目上进行了验证。我们的焚烧炉排片也是采用了一个高铬中镍合金的一个设计，它具有耐高温、耐磨损、抗腐蚀、耐冲击的性能。炉膛的设计，我们炉膛设计的话，一般的话有很多种设计的方式，比如说最重要的就是根据垃圾的一个具体情况来看，如果这个垃圾热值它比较低的话，我们比较推荐用这种逆流式的炉膛，就是最左边这个炉膛。如果是垃圾的热值就是在650到2000大卡之间，就是中间热值的话，我们会采用这种交叉流动的这种炉膛。如果是热值较高的话，我们会采用这种把这个烟道再往后移这样子的一个方式来适应一个高热值的固废的一个燃烧。我们的炉膛设计的话是要经过一个 CFD 模拟，它的目的就是让我们的这个温度在这个炉膛内进行能够分布的非常均匀，避免高温区的产生。那避免了高温区的话，那么就会尽量的减少炉膛内结焦的一个发生。同时我们在一次风的设计里面，我们也是这是我们一次风的一个布风室，就是一次风是从这个管内进入，然后向上进入到我的炉排内部的。我们也是经过了一个设计，来保证这个我的一次风进入炉膛的时候，它的配风是均匀的。二次风的设计也很重要，二次风的话是要保证炉膛内进行一个充分的扰动，来保证污染物的含量达到最低。我们也是经过了很多的这种计算来校验，来保证我的焚烧炉出口的污染物浓度是最低的。这是我们一个典型的一个计算结果。固废的一个掺烧，因为我们有些项目它们随着生活垃圾的增加，那么生活水平的提高，生活垃圾也增加，工业垃圾、污泥，还有比如说我们的太湖区域，它还会有一个蓝藻的问题。我们也是应对这种多固废混合燃烧的技术，混合的需求来开发了这种协同处置的一个技术。那我们的这个产品的话，500吨的产品和苏州3期的一个产品，苏州3期的一个进口，苏州2期的一个进口设备和我们苏州3期的自主研发设备，我们也是进行了一个技术对比，然后我们的这个技术指标也是优于国外的一个炉排的一个技术指标。它的22英的水平也是相当的低，可以看到这个结果，22英测出来是0.0015马克。这是我们实测值，这是我们垃圾焚烧系统在每一个就是节点的一个实测图。比如说在反应塔，它的这个颗粒物就很高，但是在烟囱这边的话，它这个实测这个污染物就非常低，其他的污染物也是满足这样的规律，也是我们的这个排放也是完全满足2010的一个排放标准。 我们的这个自主研发焚烧炉的话，是适合中国高灰分、低热值、高水分的一个生活垃圾，采用模块化设置，也便于安装，配备先进的自动控制系统，保证这个高效的燃烧效率。那我们的焚烧炉也是采用了一个独特的一个翻动的一个设计，那么能保证它的燃烧效果达到最优，特别适合这种低热值垃圾的一个焚烧。我们的焚烧炉它的超负荷能力也很强，然后能满足一个110%超负荷的一个需求。它的年运行小时的话是达到一个8000小时。那么同时也可以掺烧污泥，然后它的吨垃圾发电量采用高参数技术的话，也是可以达到一个非常好的一个发电效率。我们的技术也是在2012年在这个中国环境科学学会上通过了一个产品鉴定，这类技术我们的技术也是达到了同类技术的一个先进水平。烟气净化技术，烟气净化技术，我们垃圾焚烧炉的话是有一净和五出。一净就是生活垃圾净，五出是指的臭气、渗沥液、炉渣、飞灰和烟气排放，这是五出。生活垃圾排放是要根据不同的这个排放标准来设计，因为在我们国家，我们首先是有一个国家标准，还有我们自己光大环境的一个垃圾焚烧厂采用的是我们自己内控的一个标准，就是欧盟2010排放标准。那么在不同的地方的话，又有各自的标准，所以我们在设计的时候要根据各地方的这个排放标准来设计我们的烟气净化系统。对于典型的生活垃圾，满足欧盟2010排放标准的烟气净化，主要就是由 SNCR、半干反应塔、活性炭、干法、布袋除尘、飞灰固化系统、引风机、烟囱构成，它可以达到一个完全的一个烟气欧盟排放的一个标准。那么在不同的这个排放标准下呢，我们又采用不同的这个排放工艺。比如说，如果是在欧盟排放要求的基础上，它的 NOx 要降低到80毫克的话，那么我们就会在上面的这个系统再加一个低温 SCR。那如果跟我们前述的这个我们杭州项目采用这种超低排放的这个标准的话，那我们在原来的这个烟气排放基础后面，我们还要加上低温 SCR、SGH、GGH、脱白、湿法等烟气处置的一个工艺。首先讲一下我们的这个反应塔，它是用来脱除垃圾里面的一些酸性气体，它的原理其实就是酸碱中和，也就是投入石灰，然后和我们垃圾烟气中产生的氯化氢和二氧化硫进行一个反应。我们的反应塔的上面有一个非常重要的结构，就是一个涡壳。这个涡壳的话，是使让我们的这个烟气能够均匀的进入到反应塔内。那么烟气分布越均匀的话，它与石灰浆的混合就越均匀，它的反应效率就会越高。这是我们也是对我们的反应塔进行了一个 CFD 模拟。布袋除尘器的话，它的功能是将垃圾中的一个灰尘全部给去除。通过一个过滤的一个方法，把这个垃圾灰尘全部截留下来之后，然后通过把它然后把拦截下来之后，然后产生的飞灰，然后再进行后期的一个处置。我们的这个除尘器的话，设计的话也是要经过一个 CFD 的一个模拟，来保证我这个烟气能够均匀到进入我的每一个布袋里面。这样子的话，我的布袋的寿命，每一个布袋寿命就会提高。它检修率也会降低。这是我们针对一个布袋喷吹的一个处理，因为我们的布袋在运行一段时间之后，它会沾到灰尘，那么我们要间歇性的对这个布袋进行一个吹灰，然后保证它的这个高效的这个飞灰拦截性。这是我们这个部分就是我们生活垃圾处置的时候，生活垃圾烟气处置的时候需要喷入就是我们的干法这个活性炭，主要是以活性炭为主，因为活性炭它能够去除二恶英。我们的这个设计最优势是要把设计在这个使这个活性炭与烟气能够充分的混合在就是第二幅图这个状态，这样子的话就能保证使活性炭能够充分的吸附二恶英。 这是我们针对一个就是小苏打的一个研究。它的这个小苏打一般来说，也可以进行生活垃圾烟气的一个净化，但是它的这个条件目前还是比较苛刻的，所以我们也不是经常用，但是也是存在这种处置方式。这是我们的一个施法值，然后就是如果我们的二氧化硫或者氯化氢它的排放要求再一步提高，后面会加上这个系统，进一步提高它的这个脱散效率。这是我们自主研发施法它的实际排放值，这个可以看到也是相对于欧盟2010也是非常低的。这是我们的 SNCR 系统 ，SNCR 系统是放置在我们的锅炉的，就是我们焚烧炉的上部，来对烟气进行一个脱除 NOx 的一个工艺。脱除 NOx 工艺的话，后面还有我们的低温 SCR 系统，就是作为一个补充，如果是 NOx 它的排放要求更严的话，我们就会增加这个低温 SCR。就是烟气还有一个就是烟气脱白系统，就是我们垃圾电厂，我们烟气放出来的这个烟气的话，其实从外面看的话，应该是有水蒸气，但是有些群众可能对这个垃圾排放对垃圾焚烧比较敏感嘛，特别是在有些光照条件下，我们这个水蒸气看上去会有些发暗发灰，所以可能对这个民众的接受程度的话，会有点问题，所以我们在有些敏感的项目，我们会把这个烟气白色的这个烟气也去除掉，就是通过烟气加热的方法，让这个烟气排烟温度提高。那么排烟温度提高之后，它的这个水汽的饱和的这个饱和率就会升高，然后这样子的话，烟气排出来的这个水蒸气就不会产生这样的一个有烟雾的这个效果。那么我们的这个烟气排放技术的话，也是经过一个就是第三方的一个性能测试，也是测出来的结果的话，也是非常的好的。同时呢，也是在环境协会上通过了这个鉴定，然后我们的这个技术到了先进水平。就是废弃物处置技术，我们生活垃圾产生的这个飞灰、炉渣这些物质的话，还要继续进行一个处置。比如说飞灰的话，要进入这个螯合处置，然后进入填埋场进行一个填埋。我们的这个飞灰还有一种处置方式，那就是通过一个等离子的一个技术进行一个处置，也就是把我们的飞灰以极高的温度加热之后呢，它的这个有害度它就会大大降低。那么同时产出的这个飞灰它会变成一个玻璃体的一个状态，这个玻璃体是可以用作建材的。但是这种处置方式的话，它的成本也相对比较高，也是根据不同的项目的要求，进行不同的飞灰处置方式。那么炉渣的话，就是我们焚烧炉排出的这个残渣，这个残渣的话是可以用于制砖的。我们这个也是将这个是我们这个焚烧炉排出炉渣进行制砖的一个厂，还有那个炉砖产品的一个照片。提高垃圾焚烧发电厂的一个效益的措施。提高垃圾发电厂效益，最重要的是要提高生活垃圾发电厂的一个热循环效率。那么最有效的办法就是提高锅炉的一个参数。我们早期的这个垃圾生活发电厂的话，一般采用4.0 400度这个参数。那么随着我们技术的一个提升，我们慢慢已经过渡到6.4兆帕450度这样的一个主蒸汽温度。那么我们13兆帕430度，然后还有在中间散热的这个技术的话，也是在工程上进行了一个试验。还有一个就是降低排烟温度。将锅炉的这个排烟温度需要进一步降低，那么它的这个热量就会进一步的话被利用起来。那同时在这个蒸汽中采用一个中间散热技术，中间散热技术的话可以让这个蒸汽再进入到这个汽轮机中进行一个就是一个效率的提升。这个技术的话也是通常应用在燃煤电厂。那么我们也是将把这个燃煤电厂的技术也是移植到我们这个生活垃圾焚烧厂里来。选择焚烧炉方面的话，要选择这个吨垃圾发电量吨垃圾发电量高，然后超负荷能力大，年运小时8000小时的年运小时大于8000小时的这样的一个炉型。这样子的话， 我们在处置，比如说在生活垃圾量比较多的时候，我们就有一个非常冗余的一个处理量。这是我们一个焚烧垃圾电厂在蒸汽参数上的一个提升的一个过程。那么在早期的话，我们都是采用一个4兆帕400度的一个蒸汽参数，它的热循环效率是21%。那么随着这几年的我们技术的慢慢摸索，技术的慢慢提升，现在采用的这个主蒸汽温度采用了一个13兆帕430度外带就是我们的蒸汽再热系统蒸汽再热的温度达到410度，采用这样的一个主蒸汽参数的话，它的热循环效率的话可以接近30%。221是一个对于生活垃圾发电厂是一个非常敏感的一个问题，因为221是一个致癌物。221它是广泛存在于空气、土壤、水、食物中的一种物质，然后也是在我们的正常的这个生产过程中也会产生大量的221。221它是一种210，就是一种非常复杂的一种化学的一个物质，然后它包含210种异构体。生活垃圾就是在焚烧、金属冶炼、发热供热、化工生产、露天焚烧、交通运输等这一系列过程中都会产生221。221是一个非常致癌的物质，它比这个我们知道的这个氰化钾这种有毒物质还要再毒1000倍。就是如果是接触到这个221的话，会对身体造成很大的伤害。比如说这个第一幅图就是越南战争的时候，美国就是在那个丛林里铺，然后那个投射这个沉剂，那沉剂是含一种221的一种物质，然后也是造成了这个当地小孩的一个畸形。那么在这个就是在就是这个是下面右面这个图，就是我们就是乌克兰的一个前总统尤辛科，那他也是2014年的时候，然后经历了一个221的中毒，然后导致面容的一个毁坏。就是221这东西，虽然说它是毒性比较大吧，但是221排放经过扩散稀释后，它对每个人的影响其实是非常小的。全球没有一起221污染事件是来于我们生活垃圾发电厂的。221的来源的话，主要有三种吧。第一种就是我们的物料中本身就含有221，第二种就是高温的气象反应中，它会产生，就是在我的这个固废焚烧的热解过程中会产生221。那么在这个产生的221在尾部烟道，它又会再合成221，就是分解之后的这个221分子，可能在尾部的这个锅炉温度降低的时候，它又再合成，有这3个来源。那么针对这3个来源的话，我们也是采用了这3个技术来进行221的一个脱除。首先我们在前面会严格控制，有一个前处理来控制这个221，这个是。然后在燃烧过程中的话，我们也是通过一个3T 加 E 的一个原则来将221的这个分子进行完全的裂解。那么最后残存的221的话，我们会采用一个烟气净化技术对它进行一个捕捉，这样子的话就可以有效的控制221。首先是这个温度，焚烧的这个温度，焚烧的温度的话是能够完全的将221进行分解的。比如说在850度的时候，这个221的这个它的这个221是2个苯环组成的嘛，那么它们之间的键就会打开。那么如果温度再高的话，那么221呢它自己的苯环它也会分解开，那样子就可以。那么通过这个高温，就会使这个221的这个分子完全断裂掉，然后完全消解掉它的毒性。然后在烟气净化的时候，我们会采用我们的活性炭进行对残存的221进行一个捕捉。一般来说的话，我们是通过这个活性炭的点值来进行判断这个活性炭的好坏的。但是同时呢，我们也是研究发现，不仅是点值的问题，可能还有一些其他的值，比如说比表面积和亚钾基蓝值，同样也能决定这个活性炭捕捉221的一个效率。那么221的这个不仅我们捕捉221的时候，它的这个活性炭它的品质要好，它的喷射方式也很重要，所以我们选择了非常优化的一个喷射方式来增强它的吸附能力。那么通过这个221的一个我 们2·1自己场内的一个检测，我们目前光大排放的2·1的平均值是0.019纳克，是远小于0.1纳克的这个公共排放标准。结语，我们光大焚烧炉的，我们光大自主研发焚烧炉也获得了很多的奖项，比如说机械工业进步1等奖，环保部2等奖，科学协会3等奖等等。然后我们焚烧炉的话也是获得了这个获得了一个鉴定，达到了一个国际领先的一个地步。然后我们同时我们的烟气净化系统也是经过鉴定，也跟焚烧炉一样，达到一个国际领先的一个技术。然后我们的焚烧炉的话也是在国内推广的比较开，也是希望我们的焚烧炉设备的话能够在推广到全世界，能够为全世界的环保做出一点贡献。谢谢大家，我汇报完了。
Thank you so much, Professor Guo, for your presentation. I'm very deeply sorry for the audio translation in English, but we will provide you this translation, the translated presentation of Professor Guo in English later on this workshop. But I hope that you follow the presentation in English, but I'm here and also we're after the workshop to assist you in any for the presentation, or we'll reply to any question about that. And thank you so much, Professor Guo. I just want to highlight some very important points that we have a very, as I am myself, research associate at the Earth Engineering Center of Columbia University. We have a very deep relationship and cooperation on the R&D with the Everbright China and also with the Zhejiang University. I just want to say that despite the political tension between China and US, but we are working together side by side, to develop the cooperation, the scientific research on the waste to energy technologies. And one of the aspects that we want to target together is to support Africa to overcome one of the key challenges that burdens a lot of government, which is the waste management. We believe that through this scientific and academic cooperation, we want to support the government and also companies in both sides, US and China, to advance and support the African nations. And one of the examples is Ethiopia. Ethiopia now is the home of the first waste to energy technology. And thanks for also the support of Everbright China, that they support the country, to implement this facility, which I could say is an African dream. And the question is, it is feasible in Egypt and also in Tunisia and Morocco. And, it's just, the objective is to provide some scientific truth and scientific answers about how this technology is feasible in this country. And, one of the aspects that we are facing is to fight the misinformation. Unfortunately, there is a lot of misinformation that has been spread out on the media or association that, people follow it, but this is not true. That's why we want here to provide you some scientific proof, and our findings about the waste to energy technology that may help you to make the right decision. So I just want to jump in the next panelist. This time we're going to be in English. So I want to introduce Professor Zhejiang. Zhejiang is the director of the Integrated Environment Technology Research Institute of Everbright Environment. So, he can speak about the leachate treatment technologies. I know that, currently there is a lot of challenges, for municipalities and governments managing the leachate, or we call it in, Lixivia. There is a lot of challenges. And I hope this presentation, you can hear about a lot of aspects of how to manage such, challenges of the leachate. So the floor is yours, Professor Zhang.
Thank you, Professor. Can you hear me?
Oh, very good. Excellent. Just a little bit add up, a little bit sound, and you're perfect.
Okay. Hi, everyone. My name is Shao. I'd like to share with you today the nature treatment technology. And I'm going to talk about following topics. How would nature would like to be, and the overview of the treatment process currently used, and anaerobic digestion technology.
OK， 小雨，你能共享吗？能那个全屏？
复制
Full screen, please.
Full screen. 好，看一下啊。
Okay, perfect. Good. I see you now. Yes, perfect. Good. So just if you could just a little bit raise your voice so everyone could hear us.
So could you see the screen? 能看到屏幕吗？
Yes, I can see you. Yes, perfect. Good. I can see you and I can see the screen. Just if you can add just a little bit voice so we can hear you very well. Perfect.
Okay, sure.
Thank you.
But sorry, it is not in the full screen mode, I think.
Oh, okay, I see.
上面有个显示设置。
对
Oh yeah,
Okay.
perfect. Good. Now it's good.
Okay.
Yeah, well, very good.
Good now?
Yeah.
Okay, excellent.
Oh,
Very good.
okay.
Thank you.
Oh, okay,
you.
let's go. So after that, I will introduce nitrogen removal technology and membrane separation and evaporation. Those two technology category allow us to fully reuse nitrate. And finally, I will give some prospect, not conclusion, for nitrate treatment technology. So let's first look at this picture. And the photo shows Zhejiang landfill nitrate collection pond on site. You can see the geomembrane used to contain the nitrate seeping from the landfill far away. And how landfill nitrate are generated? They're from three sources. And first, water in waste always have moisture, and waste generated by biologic process, normally aerobic and anaerobic digestion can generate water and carbon dioxide. Finally, the rain, slow, and surface water and groundwater infiltration also to form landfill nitrate. And normally, a closed landfill site may continue to generate nitrate for more than 30 years. Another type of nitrate is the waste stream generated from waste to energy plants. This kind of nitrate is more fresh. Here, the photo shows an operator and was loading garbage by a grabber. And the garbage story house, understory house, the nitrate generated. You can see it's smelly one and nasty one kind of waste stream. So here's the characteristics of the nitrate. Generally, every person can produce 1 kilogram per day garbage. And the nitrate per capita can be 1.15 to 0.2 liter per day.
Hello.
It has complex contaminants composition. So a lot of contaminants, organic, BOD, COD, ammonia, heavy metals, inorganic materials, toxic materials, refractory organics. Also, the nitrate change with time and over the seasonal change. The difference can be 50% difference from summer to winter. And the different location has different flow rate of the nitrate. Also, it's high concentration, high strength wastewater. For example, the organic contaminants is represented by chemical oxygen demand. It's more than 70 milligram per liter. Also, ammonia is a big problem for nitrate treatment. It can be 1,500 to 3,000 milligram per liter. Also, it has a lot of salts and heavy metals in the nitrate. Here's the table shows the variance for the nitrate generation. It has 5 cities. You can see in summer, in June to September, it's high percentage of nitrate generated by garbage. So seasonal and regional variation is one factor to affect the flow rate of the nitrate. Another factor is management during collection, storage, and transportation. And also the composition of the garbage, water content, different, the lifestyle for different city have different moisture content. Also the fermentation conditions, because some of the water come from the biologic fermentation. And also the temperature, retention time, and degree fermentation also affect the flow rate. So we face many challenges for treatment. The first one is the variation of flow rate, also the quality of the nitrate. It's changed quite differently. And also the nitrate is very high strength waste stream. For organic contaminants, you can 70,000 milligram per liter. Ammonia can reach to 3,000 milligram. Also the TDS, total dissolved solids, can be more than 25,000 milligram per liter. Also the complexity of the composition, you can see almost hundreds of contaminants in the nitrate. A lot of challenge is for waste to energy plant. We have very limited land available for nitrate treatment facility. So I'm going to talk about this, the next overview of treatment process. So how we deal with this difficult waste stream. Here, the photo shows the nitrate treatment facility in Everbright Environment. So you can see bird view of the whole facilities. And here the larger installations. Also, so here's some data for Everbright. Last year, there are 528 projects and about 9 million cubic meter of nitrate treated and more than 700,000 tons of COD removed and recovered as biogas by anaerobic digestion. So what would be, the process would look like? This diagram shows the details, the scheme of the water recycle and zero discharge purpose treatment process. So the first part is the pre-treatment part to remove total solids, remove grit, and use sedimentation for following process unit, the biological treatment. Biological treatment include anaerobic digestion to remove CODs and AO unit to remove ammonia. After that, we use a lot of membrane technologies to remove salts, heavy metals, and other toxic substances. So we use a lot of technologies in each treatment. Here's a list of the technology or process we use. So it's divided in 3 groups. The first one to remove organic contaminants. Usually we use anaerobic digestion, include UASB, IOC, and anaerobic membrane bioreactor. This is an innovative technology. Second, we need to remove ammonia or nitrogen. So traditionally, we use AO, biological nitrogen removal. And we also developed the ammonia steam stripping, this physical chemical process. And the emerging analogs will be applied to remove nitrogen in near future. The advanced treatment for water reuse purpose, a lot of membrane technology are used. The ultrafiltration and FO, nanofiltration, RO are all used. And the evaporation and for zero discharge, like low temperature evaporation, submerged combustion evaporation, and MVR are used. So here's the shows just briefly shows the appearance of the water in different process. The left shows the anaerobic digestate. You can see the blanked one from the left to right. The right is RO effluent. So from step we change very toxic liquid, nasty one to clean water for reuse. Next, I will give you some introduction to anaerobic digestion. Here shows the anaerobic digestion's principle or fundamental mechanism. The bacteria can break down organic matters without oxygen and generate biogas. Biogas, 60 to 70% of biogas is missing. We know the natural gas, and it's a kind of energy. For anaerobic digestion, it has 3 steps. The first step is hydrolysis stage. The bacteria can break down the polymers and the complicated organics to be sugars and readily accessible materials that can be used by the acetic acids, which can be used by the bacteria. And finally, the acetic acid can be formed as a methane by following chemical equations. And the diagram shows the step. I'm not going for the details. And normally, anaerobic digestion, like cylinder, shows the left photo. So any advantages, it's very high efficiency for organic removal. And also more important, it can achieve energy recovery because every ton of liquid we can harvest 50 to 70 cubic meter biogas. And that is missing, many components is missing. That can harvest it for energy. Also, the investment and operating cost is quite low because we don't need to aeration and very low mixing energy required. Because the bacteria in AD grow very slow, so low sludge yield can be achieved. And also this technology is very developed for many years. It's very reliable. Also, there are drawbacks, disadvantages of anaerobic digestion. Firstly, the effluent is not good as anaerobic treatment. The effluent can have more than 1,000 milligram COD in the water. But we developed the emerging anaerobic membrane MBR technology, which we combine anaerobic digestion with ultrafiltration membrane. This combination can greatly improve water quality. So we can achieve extreme clean water after this treatment. Also, another disadvantage for AD is the total nitrogen can't be removed. And also the bacteria in AD is sensitive to temperature, pH, and toxic substances. So we would maintain the tank, the reactor to 35 Celsius degrees. And also because the bacteria grow slowly, so start time would be longer than anaerobic treatment. Also, odor problem and digestive treatment is another problem. So here I introduce some very typical anaerobic reactors we used in our project. The first one is upflow anaerobic sludge blanket reactor. Here shows the diagram of the inside of the reactor. You can see the key part is the third one, three-phase separator. This is the core part of the reactor. It can separate the sludge and the effluent and the biogas. So its design is quite important for this technology. So here the diagram shows another type of anaerobic reactor. It's called the inter and outer circulation reactor system, IOC. We developed based on USB. You look at its overlap of two USB together for the configuration. So it can be more efficient than USB. We also use computational fluid dynamics CFD tools to optimize our designs for anaerobic digestion. So here's the example how we optimize our design for anaerobic digestion reactor design. We recently developed innovative anaerobic membrane bioreactor. This is a very advanced AD technology. It has three advantages. The first one is very high effluent quality can be achieved. The membrane can block almost all the solids in the reactor. So the effluent quality, the SS can be almost zero. And also organic load rate is quite high compared with the traditional anaerobic digester. And because the organics and the bacteria can contained in the reactor, so biogas generation is quite high. Thus, the higher energy recovery rate can be achieved. Here are some of the diagram of the MBR system. It can be divided by two types of MBR. The first one, we put the membrane inside the reactor, so it's submerged MBR. The other configuration is we separate the membrane unit to the ID reactor, so it's called side stream MBR. And we also use two types of membrane, the plate and the tubular. The last picture shows the effluent water quality comparison. The left side, the dark one, is the traditional anaerobic digester effluent, digestate. And the red one shows after membrane treatment. So you can almost transparent. We currently is constructing the first MBR demonstration project, full-scale project in Suzhou waste-to-energy plant. We spent 3 years to study, doing many pilot study and lab research. Probably after this installation, it's probably the first one MBR process to treat leachate in China. So here shows the photos currently under construction. Next, I will talk about nitrogen removal technology. You see, this photo shows the lake eutrophication. It's in Taihu Lake in Jiangsu province, China. So you can a lot of algae. You know, the water body eutrophication, mainly caused by the excessive phosphorus and nitrogen discharge in the water. So when we control ammonia and the total nitrogen emission, and here are the standards and the pollution problem. For ammonia, its main problem is cause fish dead. According to US EPA ambient water quality standards, 1.9 milligram total ammonia can cause fish acute toxic. Total nitrogen can cause eutrophication of lakes, rivers, and estuaries. So, what leachate? How leachate contains the ammonia or nitrogen? We know municipal wastewater, domestic wastewater, the ammonia concentration is only 20 to 50 milligram per liter. But for leachate concentration, very high, 1,000 to 3,000 milligram. So it's 100 times of municipal wastewater. But the national emission standards for leachate is quite stringent, very strict. For municipal wastewater plant, the total nitrogen is below 50 milligram per liter. This is a discharge standard for the domestic wastewater treatment plant. But for the landfill leachate treatment, it's 25 for ammonia, and the total nitrogen is 40. But you can see the leachate concentration is 1,000 and 3,000. So to achieve these standards, you must remove nitrogen. The removal rate should be 99%. So very high removal rate you must achieve to meet the emission standards. So this is a challenge. Currently, most used process or technology is anoxic, that is AO process. It divided by 3 steps. The first one is called ammonia oxidation. In this step, ammonia is converted anaerobically to nitrate by bacteria. Then step 2, the nitrate is converted anaerobically to nitrate. This step called nitrification. After that, we add carbon sources in anoxic condition, which means no oxygen. So those material can change the nitrate to nitrogen gas, which called electrification. So this is the fundamental principle for this biological process to remove nitrogen in nitrate. So here's the equipment or some we used for this process. These 3 pictures shows the aeration process or equipment we normally used. The first one is micro bubble diffuser. It can generate small bubbles from bottom. The middle one is jet aerator. And the last one is surface aerator. We normally use jet aerator in most of our nitrate treatment facilities because it's more reliable and higher oxygen transfer rate can be achieved. Also, we use all kinds of pumps for this process, like centrifugal, slurry, and screw pumps. We all use this pump. We all used, and also mixers. Here's illustrate some kind of mixers and blowers for oxygen for aeration. So we use the positive displaced blowers. This is quite reliable and low cost, but with the energy saving and carbon neutral requirement, we changed it to high-speed turbo blowers recently because more energy efficient. Although the price is not is quite high, but the energy saving can make up this investment for just 2 or 3 years. And also, we need to treat the sludge generated during biological treatment process. So we need to dewatering the sludge. And the rotary centrifuge and belt dewatering equipment are widely used in nitrate treatment process. And also, we use membrane after the AO process. So it's typical MBR technology. So it's combined biological treatment and the membrane technology. Besides, we use biological treatment process, AO. We also developed the physical one to remove ammonia from the nitrate. We use steam stripping technologies. We know ammonia is volatile in the waste stream. So we use steam to separate from the nitrate. The advantage is it's a very small footprint versus biological treatment process. Also, we can achieve ammonia recovery. So this would be very promising for resource recovery trend. And also it can be controlled, operated automatically. The drawbacks of this technology is It's high energy required. It's normally consume 80 to 100 kilogram steam per cubic meter nitrate. Also, this technology require very high ammonia concentration in your waste stream because according to the mass transfer, higher ammonia concentration can achieve more ammonia recovery rate. So here shows the installations in our project. We also doing some pilot study, and finally we build the full-scale installations in our EV project. And here I illustrate the Zhejiang landfill nitrate treatment plant. You can see the right side, we generate fertilizer and from the nitrate treatment, use steam stripping technologies. It can be very welcome by the farmers for their land use. We are currently just finished another project in Suzhou waste to energy plant. It harvest or recover the ammonia just for the gas emission treatment, because we need to NOx reduction during our flue gas. So we recover the ammonia from nitrate and use the ammonia to remove NOx in the flue gas. There are emerging technologies to remove nitrogen in nitrate. LMX is a very emerging technology. It's use a special red bacteria. This bacteria can find a shortcut compared with the nitrification and the denitrification pathway. So here shows the shortcut. It can't be nitrate cannot. It only change 50% to nitrate, not to nitrate, and another 50% ammonia can react with the nitrite to further step to nitrogen gas. So how experts assess this technology? Like Pierre Mercati says, this very high energy, less energy wasteful approach. And this approach to energy neutral for waste stream nitrogen removal. So this is what experts say about this technology, LMX. We find 22 species in 6 genera of the bacteria have this function. Here's a list of the common find LMX bacteria. And what's the advantages? So the first one is very low energy consumption because it's the bacteria use a shortcut. So about 60% of energy are saved by this process. Also, the nitrogen removal rate is quite high. It's greater than 0.8 kilogram nitrogen per cubic meter per day. It's more than 10 times removal rate compared with the current AO process. Also small footprint. More importantly, this technology can be achieved very low carbon emission because traditional AO can generate very high greenhouse gas emissions. Also, the bacteria, this red bacteria grow very slowly, so excess sludge yield very low, and the sludge can be less problem. So here shows our pilot study in the laboratory, and the red one shows the bacteria grow attached on the plastic. We also cooperate with the universities to conduct this research. And next, I would like to talk about membrane separation and evaporation technology used in nitrate treatment. Here, the diagram shows the particle size of different matters, contaminants, particles, like cells, bacteria. You can see the human hairs, clay particles, all kinds of particles in water. So from the very fast one molecules to the larger one like the organic debris and bacterial flux. So a very substances in water can be think of a kind of particles. The only difference is their size. So membrane technology is just physically screen these particles. Here illustrate the different pore size and the energy required or pressure required to filter these particles. You can see wastewater inlet from here, and the more larger size of the pore size, less pressure required. And the most required is the reverse osmosis membrane. That means more energy required, but cleaner water effluent outlet can be achieved. And also the fouling propensity is likely to happen. There are 4 types of membrane normally used. The first one is microfiltration membrane. Its pore size is 0.1 to 1 microns. The second one is ultrafiltration membrane. It's 1.001 to 1.1 microns. And the nanofiltration is even finer pore size. And the RO is the most fine membrane. It's semi-permeable membrane to remove ions and molecules by pressure. And there are 4 configurations of membrane: tubular, hollow fibers, spiral, or plate. So we must use these 4 configurations we can use in nitrate treatment. The largest pore size of the membrane is the micron filtration, MF. So we normally use it for biological treatment for sludge and water separation, like AO. Here shows the AO process and the real photograph of the MF module. And here's the MF parameters. Ultrafiltration are also used for MBR. And another usage is for chemical subtly. Chemical subtly is remove the calcium and the magnesium removal. Normally we use the sedimentation and clarification, but for membrane it has several advantages. You can achieve very high water quality for the effluent. Also, it can be a pre-treatment for the subsequent RO process. Also, very high efficiency of hardless elimination rate can be achieved. It's small footprint, and operation cost is relatively low. Nanofiltration. Its purpose is to reduce soluble CODs, like humic acids in the nitrate, after ultrafiltration. And also it can be a pre-treatment process before RO. And here shows the diagram of the process and what the nanofiltration module looks like. Finally, I briefly introduce the RO membrane. It's just the principle I don't want to talk about more. You can see what it looks like and the configuration. It can be configured by series or parallel. And finally, I would like to introduce you some zero discharge technologies. Evaporation is the final step to achieve zero discharge. Currently, the first evaporation technology we currently use is submerged combustion evaporation. Simply to say, it's just use the biogas or landfill gas to burn in the chamber to evaporate the water content. So we achieve zero discharge. So it's deal with very refractory, corrosive, thick, very hard to treat nitrate. Another evaporation technology we are under development is low temperature evaporation. We call it LTE. The fundamentals are the mechanism is like a cloud and a rain. It's divided by two unit process. The first one we use air and dry air and heat to make it humidation, make it humid, like we form the cloud. The second step is like the rain, so we achieved the clean water. So it's like the cloud and rain, the principle would be like. That step called a condenser. So you compose two parts, evaporator and condenser. So what's the advantage? It's only require low-grade heat, so we can save energy cost and the low operation and investment cost. So you can reduce 20%. And also high water recovery rate and better effluent quality can be achieved. Here are some illustrates the module design and large-scale applications. Another technology we developed is the electrodialysis technology called ED. We use electric field to separate ions in the waste stream. And here's the ED module. Its advantage is very high plus efficiency because we use electricity. It can separate the cation, anion by charge. Also, it can achieve very stable operation conditions, very compacted treatment unit. Another emerging technology for salt removal is forward osmosis technology. is currently is not is under development. It's just opposite to RO, but it has advantages such as low pressure, thus low energy consumption for this technology, and also high water flux and less fouling, less fouling, and also strong adaptability. So finally, I would talk about the prospect for leachate treatment. Just think about a typical wastewater treatment plant. Currently, it's just the center of cost. It's not carbon neutral. It requires energy input. It generates problems, sludge. So all this cost will achieve the clean water. This current typical wastewater treatment plant. How about generate energy or energy recovery or less sludge and or recovery resources while we get the clean water? So think about future. Think about future of the wastewater treatment plant, leachate treatment facility. So we are trying to do this. Here's the diagram we plan to realize in near future. The first one, the leachate come to pre-treatment, remove grades and excess total solids. After that, we use an MBR technology to harvest the recovery, almost all the energy in the organic matters to generate a biogas for pipe, for heating, for electricity generation. After that, ammonia come to the next step. We can use steam stripping to recover ammonia to make it a nitrogen fertilizer. Or we use LMX to get the valuable red bacteria sludge for sale. And after that, we use electricity EDR to separate the source from other leachate. We use low temperature evaporation technology to recover source. After that, the water stream, we use RO to get clean water for reuse in waste to energy plant. So this is our plan to achieve leachate energy recovery, water reuse, and nitrogen sorts and recycle. So here's our team, and we have 33 people in our institute, in my branch. So thank these guys to support this presentation. Thank you all today. Any questions I would like to answer? Thank you.
Thank you so much, Professor Zhang. Very great presentation, and well, I learned a lot, actually regarding a lot of technical aspects of how, from the leachate that, it's considered as, challenge is become a resources. And, in fact, several countries in North Africa, they are facing the drought due to the climate change. I think, the process to transforming, the leachate into clean water and also fertilizer, that could be very interesting, solution to consider, and, that could resolve a lot of challenges in terms of the water scarcity and also for the agriculture. Knowing that 60% of the arable land in the world are in Africa. So it's very, very important. So thank you so much again. And
thank you.
We arrive at the end of this first day of the training workshop. I hope that you all, it was very interesting for you. You learn a lot of things, and we will move to Q&A, question and answers. I know there is we received some questions earlier, and we're gonna ask each one of you if someone wants to ask questions. So okay, so someone raised their hand. So there is before I will give you the floor to ask question. If you could just introduce yourself, your institution, and where you come from, and that will be easy, and we will be very glad to answer it. So I will give the floor to Yasmin Yasso.
Okay, Mr. Reda. I also pay attention to the questions. I try to have an answer and a communication with our participant for these comments or questions.
Okay.
The question one is about what about the effects of the Chinese state in light of climate change? What about the effects of the Chinese state in light of the climate change? Maybe I say some things, and also all the participants from Chinese side, you can say something about these questions. In my opinion, very early, maybe in 2000 or about that time, the China already have pay attention for climate change since the Kyoto Protocol, and also later the Paris agreements. Also, we join them. So nowadays we have the national strategy for 2030, the peak carbon emission peak, and 2060 carbon neutral policies. That is the target of the national, the whole country national. So our every sectors, industrial sector and every sectors should follow the policies, and that means we already is a national level respond for the climate changes. In my opinion, maybe focus on the waste. In my presentations, I have one slide about the carbon sustainability of the waste energy, replace the landfills, reduce the methane emissions effect for the greenhouse. In China, we have a large amount of waste to be burned, waste to energy. So exactly reduce the methane from the landfill of the waste. According to the estimate of our research teams, from waste to energy, we made a contribution about the 0.8% of the carbon emissions reductions, if you consider methane effect of the greenhouse. So this is we use the very low energy, but we can make a big contribution for carbon reductions of the whole countries. So that is the effect of the waste to energies. That, in my opinion, is a positive effect for the green gas, the reduction in China. Okay, for question one.
Okay, thank you.
Okay.
So thank you so much for that. Just someone here, there is two people raised their hands. I just want to give them if they could.
Okay, maybe Reda, I can continue for the questions.
Oh, yeah.
The question two is that China is also characterized by the industry. So what about the factory waste and maybe I guess the industrial waste, and what are the new measures for the optimal use of this waste? Yes, the China have a huge amount of the industrial waste. So according to our industry process, also maybe easy to understand to reduce first and recycling, and then to dispose. Early, maybe several years early, industrial waste always mixed with the municipal solid waste in China. Since last year, we have issued the solid waste law by our Congress. So since then, industrial waste should be separated their way. There should be divided by the municipal solid waste, and their waste be careful. But nowadays, besides the recycling and major of the industrial waste, still coal-fired or coal disposed by the municipal solid waste in China or still. But for coal-fired, maybe it's a new topic, new challenge for the waste energy. So also from the scientific and the industry, and also I guess I believe the Everbright and the company have a much more experiment for their waste, the industrial waste, and the municipal waste at the same time, and in their waste to energy plans. This is my simple answers.
Okay. Thank you, Professor Lee.
Okay.
I think there is other questions. So Yasmin Yasso, do you want to add? Do you want to present your question here?
Okay.
No. So I'm gonna pass to Ahmad.
Yes, Ahmad speaking.
Okay. So yes. Thank you so much. Yeah, I can hear you. Yeah, if you could just introduce yourself and then and then ask your question. Thank you.
Yes, with pleasure. Myself, Ahmad Reis. I am from Egypt. I work as a health and safety environmental specialist at the Siemens company in Benzoe power plant. It's the largest power plant in the world, working in combined cycle. I hear we have in our plant EDI as a technology for water desalination, and also RO plant, reverse osmosis, and we have pre-treatment and water desalination also. It's classic type vessels for ion exchange. That's all regarding myself. I want to thank you for this great lectures. But my question regarding this lecture, I want the PowerPoint and the video record. Some guys send the WhatsApp group on the chat box, but it's inactive. Please, could you please add my numbers to WhatsApp group, or you can send your number recorded as a WhatsApp to send me the. I will send you a message to send me the PowerPoint and the video record. That's all. Thank you.
Thank you, Ahmad. I just want to highlight, thank you so much for your participation. And I just want to assure you that all this material, the record of this training, will be available soon and at the WTRT Egypt. And I will coordinate with Professor Mohi, regarding all this, technical aspect. And I'm sorry, we're going to provide also the English translation for the Everbright, presentation for Professor Go. So just, I don't know what's up. I think I will provide you my number, no problem, my WhatsApp number, and also my email. If you have any questions, we raise question, and if you want to collaborate eventually, we're very pleased to do so. There is someone here raising his hand. So Dihash. Yeah.
شكرا رضا.
There is some issues on your
for
voice.
people from China, good afternoon, maybe good morning for someone. Good morning for someone. Good evening for everybody else and other country on the side of the world. So I would like. So I have to present myself. I'm Abu Dihaj Tabi' from the Sustainable Development Department of Morocco, especially the regional direction or the territorial direction of Beni Mellal Khnefra. So I would to thank everybody for this training workshop, and I really hope that we plan an exchange workshop where we can also show Moroccan experiences in that field. So first, allow me to inform you briefly about our national program of municipal solid waste management that consists of 5 major components. First, establishing a municipal solid waste management prevention plan. Second, collection and transportation, setting up valorization and landfilling center, including sorting center and its supplements. Also, I think setting up valorization and landfilling center, as said, and closure and rehabilitation of old anarchic waste disposals, and the last building transfer stations. So we have to remember so that municipal solid waste management is a specific attribute of the territorial collectivity. The government gives only financial and technical support. So the major problem is with the moisture or water content for the first speaker. So we have about 65% of organic waste, especially fermentable waste. So when we say fermentation, that's mean water production. Then also we have social behavior in Morocco makes that our municipal solid wastes are very, very wet. We don't house salt our waste. So we know that in Europe and in other countries in the world, efficiency is burning them when we talk about incineration. My question is it efficient and successful that we burn our municipal solid waste in consideration of humidity of our MSW and the performance regarding to the LHV, lower heat value, or the lower calorific value of that kind of waste? This is the first question. The second, can you confirm that there is no adverse, harmful impacts on air, climate change, and carbon neutrality regarding to the Moroccan strategy aiming at reduction of greenhouse gases? As I said, so currently we are just landfilling municipal solid waste.
Okay, thank you so much. Yeah, Professor Lee, do you want to add something?
Sorry, I think it was an interruption in my intervention.
Okay.
Yeah, thank you. We received your first question, so just to move to.
Okay, I
don't know. Reda.
Okay,
sorry
I want to say. I'm sorry.
I said currently we just filling the municipal solid waste. The choice of incineration is a political decision of our government. So we have major problems with leachate treatments also, especially when we talk about heavy metal. I noticed that the last speaker, when he talked about the leachate treatment doesn't or didn't talk about the heavy metal concentration, the HMC. So the only solution adopted until today is its storage. There are attempts for treatment by reverse osmosis, as he said, but it's either infectious and fruitless or too expensive. So with your solutions, how much does it cost in average to treat cubic meter leachate? And thank you very much for all the speech.
Okay.
Thank you.
Okay.
Thank you so much.
Thank you, Mr. Reda. I try to communicate with these gentlemen for the first, maybe later the second, and I hope the Everbright can add some more answers for these gentlemen questions. For the first, for this objective of the training workshop, we want to set up the platform so we know each other's and then we keep contact for the more technical and the more practical the situations for the Morocco or others. So this is my first suggestions. And the second is for the very specials for low heating value or for high moisture waste. Is this possible for the waste to energy or for installation? My answer is it depends. According to experience of China at the very early of the maybe for example in 2000 in China, also we face the same situation of the waste. But we deal with this waste. For example, we can save the waste for several days to leach of the waste and then higher their heating value and then the burn in the stock race. This is one way. And another way is we use the food as batter, circulating food as batter mixed with the coal and burn the waste. When you consider waste to energy, is only depend, you do not have other better measure to deal with such waste in the city or among the city. So the short answer is it is possible for deal with the low high moisture or low heating values waste according to the China way. I believe the Everbright and have more experiments we can conduct. It depends. It depends the heating value. No, what extent of the heating values. Maybe in a shortened in China's maybe we about 1,000 kilocalories per kilometer is available for the installations. It depends. So the third is the for the installation. It depends also how to consider the capacity. Capacity and some investment cost. It depends. So this is the comprehensive. You should consider more and more effective for to adopt waste energies. I hope we can continue to discussing these issues, and also I encourage you do some analysis for this waste to understand more details. How about the moisture? How about the heating value? So we can make clear decisions. The second question is also for green gas related to the waste to energies. Maybe, but it should be do more work. Just in China also we also still do more work for the greenhouse reductions related to the waste to energies. This is my short answers. gentlemen and Reda. Any Xiaoyu, do you have any comments for the questions of these gentlemen?
Yes, I would like to address the greenhouse gas emission or climate change issue. I think currently the baseline is comparison with the landfill. So it's more like a neutral carbon negative for waste to energy plant under current baseline. And for China, according to the international standard of the greenhouse gas emission criteria. And with more landfill closure in future, and the baseline would be lower for greenhouse emission. So it may be positive emission for waste to energy plant in future. So how to avoid from current carbon negative to future carbon positive? We are developing several solutions. The first one is to use anaerobic digestion to harvest the biogas instead of fossil fuels through replacement. The second one, we developing CCUS technologies to capture carbon dioxide from flue gas. And also we know in biogas, there are 30 to 40% of carbon dioxide in biogas. We also want to use that part of carbon dioxide to grow algae and some biological CCUS technologies to absorb and you use this part of the carbon dioxide. So we want to change waste to energy plant to carbon sink, not to the carbon source. This is just what my opinion answer to your question. Thank you.
Yeah, thank you. I just want
okay.
Also,
yes.
Yeah,
yes,
you can jump
thank
in.
You, Mr. Reda. Yes, thank you, Mr. Reda. And thank you, Professor Dr. Li and Dr. Zheng. And I'm from Everbright Environment, and I'd like to echo in the answer of Professor Dr. Li and to the question in terms of the calorific value. And actually, the choice of the technology depends on the composition and heating value of the waste. Whether we choose the fluidized bed or great incinerators. Actually, Everbright Environment has developed our own great incinerator technologies. And with that technologies, and for those municipal solid waste with calorific value, and I think around 1400 kcal per kilo, and it's our great incinerator is applicable. And
we cannot hear you.
Yeah, it disconnects. So basically, I just want to add something to the hash. So obviously, here going back, Jiang, you want to continue, Jiang? Yeah, you are in mute. You are in mute.
You open voice. You should open voice.
Okay.
Yeah, there we go.
Okay, yeah. So with the calorific value is raised to around 1600 or 1800 kcal per kilo, and we can the waste can be incinerated without any additional fuel. And so we are open to discuss about the most suitable, the BAT technology for
for your country, and just if you just share the composition and the kind of value of the waste in your country, and we are open and glad to have further discussion about that. Okay, thank you, Mr. Reda. That's fine.
Yeah, thanks so much. So also, I just want to add that at Columbia University in New York, so we our research center has studied all the options for the treatment of the post-recycling waste, and there is only two options. That's it's common, very common, which is either the landfilling or the waste to energy, which is the combustion. Today, with the recent development of the waste to energy in China, knowing that their GDP is very low compared to the US or Europe, so basically they succeed to develop the waste to energy at a very competitive cost. That today, some low-income countries like Ethiopia are capable now to have a facility, and you have to visit, the plant in Addis Ababa, and you can see their waste. It's a very low income, low calorific value. It is mostly organic, and they succeed on on the combustion and also for the treatment of the greenhouse gas emissions, and also how to reduce even the pollution in the city, because it was very crazy with all the challenges of the landfill. So, and one of the other aspects, which is for myself, it's very important, is the finance. We can talk about a lot of things about what's the solutions and the literature treatment and the waste to energy, etc. But the problem that occur is the finance. Through the Belt and Road initiatives, and this could facilitate the countries to receive the funding from from China, and through the cooperation between the U.S. and China, I believe that the cooperation, such a cooperation, we believe that this will enable countries to get this kind of technologies, through the cooperation of the finance. So that's why, on tomorrow we're gonna talk about the PPP, the private-public partnership, and how this instrument could help countries implement and build such facilities, because the finance is another stuff that we will discuss about it tomorrow. And also we will discuss about other comparison technologies like the MBT, the mechanical budget treatment, the combustion, what is the cost competitive of each of one, and how it could support each country on terms of the sustainable circularity of the waste management. So I want to give the hand to ICCWtE. ICCWtE, if you could unmute yourself and
it's the same,
provide
it's the same because I was connected.
I'm sorry. Yeah, there's two. Yeah, I'm sorry. I'm sorry. It's all right. So I'm gonna give the question to Professor Mohammed Sor.
Hi, fine.
Hi, Reda. Hi, Reda. How are you?
Yeah, perfect. Good. Thank you so much.
Yeah,
I hope you're doing good.
Yeah, I'm really very happy to see this very, very nice training workshop and join from the beginning to the end. I just missed the French part because I couldn't follow the French part. Anyway.
Sorry about that.
Okay, so
but I just want to say to everyone, we're gonna provide all the material, the recording, and also with the translation to Professor Mohi. So you can, because Professor Mohi is our representative of the WTRT of the University of Columbia in Egypt, also at Care University. So we will provide everything, and the website, so you can upload and you receive everything. Okay.
Yeah. So I like the last point you mentioned. Actually, that's actually finance and funding and convincing government or investors to be part of this business, because I believe the future for our countries, like these developing countries, will rely very much on these kind of technologies of having some energy from waste, because actually this is, in Egypt, we have more than 120 million tons of waste, which can be theoretically converted mostly to energy. So the point is, as a Moroccan guy said, actually, about the type of waste will be different from one country to the other. And maybe if we also have some kind of study about different types and what technology will be suitable for which type of waste and things like that. I would like to have a very good collaboration, close collaboration with Chinese. I had also some collaboration with some professor from Tianjin University. So I would like to also have this kind of collaboration and work on that in the near future, on the long run as well. I would like, my hope, to see this kind of technology applied here in Egypt. I mean, from the simplest to the highest technology. And I will try so hard to get government people to actually to come to this kind of meetings. I think we have 2 now in this meeting, and tomorrow perhaps, if you can, Reda, have maybe 1 hour at the end to have brainstorming and think about the way of making this kind of collaboration productive and successful, and within a certain time frame we can achieve something.
Yeah, sure. Thank you so much. Thank you so much. And then definitely, I just want to add something also, that the next year it's going to be, since the COP28 will be held in Emirates, you know, and you know, we will organize some sort of conferences, maybe in Dubai or Qatar, that we can, because Qatar, you know, Emirates are leading the way in the Middle East in terms of the waste energy technologies. And I could say that I think the Arab world, you know, needs to take it's become the lighthouse, you know, to advance the technology and to phase out the landfills for the energy transition. And we hope that this, you know, effort with collaboration, international collaboration with US, Europe, and you know, China, to collaborate all together to advance and support countries, you know, in terms of especially Africa and also North Africa, how to equip and support them in terms of academic, technical, scientific aspect, and the financial one, you know, in terms of the development of the waste energy. So, Professor Lee,
yeah, thank you, Professor Mohi. I'm very glad to know you have a much better background about the waste, and also maybe you say the Tianjin University.
Yes.
You have, yeah, maybe I have also a close relationship with Qichao, Dr. Qichao Ma. She is also she early have do some research work in Columbia University early. Maybe I guessed her, so it's very good. And also, just I say early, why we heard the training workshop is our object from our university and also from Everbright, and exact from the China. We have the common interesting to cooperation with you and others developing countries. For us, we have common interesting for the research, and also for our industries that they have potential business, the market, and also it's very good. And also, I think we have much more opportunities to cooperations. So I'm very glad to cooperate with Mr. Reda and Everbright. And also after the training workshop, we can focus on some the same common topic. We can do some research, and also it's my hope. So okay. Thank you, Professor.
Yeah, thank you. Well, Professor Lee, I have a question for you from Hafsa Ben Brahim. She asked about, you know, ICO. Yeah, please. You call
Qichao Ma Qichao.
No. Yeah.
Okay.
Yeah, please. She asked, please justify the choice of incineration technology in China compared to other less polluting technologies?
Okay, I see. I try to answer these questions maybe.
Oh, okay, you did. Okay.
Okay, I have to say this for this.
Okay, that's good. So I have someone here raise his hand. So it's
yeah.
I don't know, RC member.
Yeah, RC member.
Yeah, could you
Hello.
just introduce
Yeah,
it? Yeah,
can you hear me?
Hello. Very good, excellent.
Yeah, the reason I'd like to ask something, because according to the World Bank, still between a comparison, because I'm living in Canada, I'm Egypt, but the reason, we have many projects in Canada that had been put on hold due to the very high cost of applying, for example, the imposed environmental restriction we have. But if we talk about the Middle East, because according to the World Bank, for example, the option of incineration is still one of the most expensive one related to other way of, like in Europe, it ranges from $600 to $1,200 per ton. In USA, it's a little bit cheaper, it's still $600 to $800. In China, yes, it's between $190 and $400, but if we compare that to other way of handling the waste, especially if we are talking about developing countries like in Africa, and that's something, because even the operational cost of the plant, waste to energy, actually still natural gas or solar or coal fire are more economic than the incineration, and even the cost per megawatt still high. So I think that's something, and the reason I'm asking, I know China is always one of the countries that I do admire. They're looking for between technology and economy. It's not only about technology, and economic output should come. So based on that, how this, because here's come the problem, reducing the cost. Do you think if we don't reduce the cost, there will be a hope if there is no imposing laws? Let's be realistic. Environmental has been respected because of laws, not because initiative from personnel.
Okay, Mr. Reda, I try to answer these gentlemen, and I hope that maybe from Everbright you can answer more. Exact incineration more expensive compared to the other method, especially for the landfill. It's true. When we talk about waste to energy or incineration, we should meet the minimum requirement of these technologies. For example, according to our experiments of China's, the GDP or some economic level of these areas or this city should be at some levels. For example, in China, maybe we up to the 4,000 US dollars, the GDP. This is maybe this is a level. So if you up to this level, you face the waste, the challenges. You face the waste problem. You should be deal with. So landfill for some areas, for some cities, maybe Casablanca or some cities, you lack of the space to landfill or to others. And also, just you consider the waste, they have energy, so they can generate the heating or electricity. So these are the advantages. And another is according our experiments, compared to the developing areas, Japan or Germany or others, in China, our industry company more, in my opinion, is more cheap, more reasonable the cost for equipment, for construction, for operation, and for, in my opinion, for comprehensive reduce the cost of the waste. So that is the variable technology available technology for some developing areas in developing countries. For example, in South Asia or some Southeast of Asia, some others developing countries, they have the big city or something. They face the big challenges of the West. According our experiments, if you use the China's science experiments and including some the business models, this is available for us to consider the waste to energy is possible. So this is why we try to provide some training or some communication, some platform to understand and to hope to provide some available model to treat waste in some developing country. Is my consideration. Okay. Any comments from Everbright for these questions? iPhone?
Yes. Thank you.
Yeah, you're welcome.
Yeah, I'd like to add something. And as we Everbright Environment, we would like to offer the best value for money solution in terms of waste incineration. And actually, I can give you some figures that, like, of course, the capital investment and operational investment varies in line with the local economic development level and the material cost, etc. And the average capital cost of an waste to energy plant, I think it's a range from 800,000 to 1 million RMB. That's about 100,000 US dollars to around to 200,000 US dollars per ton of waste. That's the capital invest, and the operational cost, it's range. I think it's around about 20.
Excuse me.
Yes.
Can you repeat again the numbers related to capex and the opex for the waste to energy, utilizing the direct incineration process?
Yes.
Can you repeat it again?
Yes, the capex it's around 100,000 US dollars per ton of waste to 200,000 US dollars per ton of waste.
And the capacity of such a unit? I mean, how many
ton of waste per ton of waste incinerated? Per ton of waste incinerated. Yes.
Oh. Yeah. Okay.
It's for the investment.
Yeah. I understand. That's what we're saying. It's between, as you said, 100,000 per ton, just the capital investment. So if we come to a city like
100 to 200. So that varies. That's the range. It's a range. Yes, it's a range. Yes. So I think it's not such kind of expensive technology and yes. So.
I just want to add in also that also if countries, if just add to Zhang, and also countries could support eventually the industry by providing a feed-in tariff, also that could support, in terms of the feed-in tariff, the taxation, also, that could, provide some sort of oxygen, to support to develop the technology, because if we compare the environmental, aspect of the degradation of the environment using the landfill or open dumping, if we analyze all the associated costs, we're gonna figure out that waste energy is less expensive on the large, 10, 20 years horizon. So we should not focus only about the cost today, because to protect the environment, it has a cost. And definitely, the best available technologies to manage the waste is the waste to energy, because we recover the material, the energy, in a better way than the landfilling. But still, there is a lot of, in terms of the policies, as I said, the feed-in tariffs, and also the important thing is about international cooperation, the scientific cooperation that could support countries to develop technologies and to choose the right technology. Because unfortunately, in the world of the waste energy, there is a lot of sellers of the miracle technologies that unfortunately doesn't work. So that's why the best thing is through academia, the research, the scientists that could support the government to take the right decision and to fight the misinformation and disinformation regarding the waste to energy. This is our aim, and for this workshop to provide you the latest scientific evidence about the waste energy. And also we have at Columbia University, we have studied all several waste energy plants from the Europe, in the US and China. And Chinese, they succeed to reduce the capex of the waste energy technologies, because in the US we build one plant per in 20 years, but in China they build 40 to 50 plants a year. So there is some sort of economies of scale, and also through China invest heavily in the R&D, in the research and development. So they support the industries to go above and beyond, on just a thing, because if we want to develop, we need to develop the research, our capacity of research to find solutions, complex challenges for a scientific solution for our complex challenges on the environment. So thank you and if anybody has a question, I will.
Yes, may I clarify something,
yeah.
Dr. Reda?
Yeah, Dr. Khalid. Yeah, Dr. Khalid, please go ahead.
Yes. What I'm trying to tell that, as you said, we do have different technologies related to the treatment of mainly of the municipal solid waste and the sludge as an outcome from the wastewater treatment facilities here available in Egypt. But nowadays, we are in advanced process that we have set here in Egypt, a feed-in tariff for the waste to energy treatment facilities. But all of a sudden, we start facing a severe problem regarding the investment requirements from the different countries worldwide, and very specific after the latest financial crisis that has been taking place because of the Ukraine and Russian clashes and all of this stuff. So nowadays, our feed-in tariff became not feasible to the investors. And when we receive some sort of offers regarding the waste to energy with direct incineration process, we found that the costs related to the capex at $100,000 per ton of the municipal solid waste to be processed, nowadays it became up to 250,000. I don't know why. If you are talking about R&D, and Dr. Muhyi can correct me in this, that the whole waste to energy treatment facility is finally a thermal energy power station, where the thermal energy power stations nowadays in Egypt, in accordance to the current applied prices, doesn't exceed more than $1,200 to $1,300 per kilowatt in stone. Why such doubling in prices or tripling the price from the investment point of view related to the direct incineration waste to energy?
Okay. Yes. Okay. So, do Zhang, you want to take this question, or you have any insight for that? As the Professor Khalid mentioned that the country, the Egypt, is more advanced on the waste to energy technologies, but the cost is very challenging in terms of the cost. I think we already talked about it on the previous, which is mentioned the cost, the capex, and provide some figures. And I think from my point of view, we could provide some sort of pre-feasibility study, through Columbia University in Zhejiang altogether, and including the industries, and we can provide you some sort of pre-feasibility that will give you some analysis instead of getting ready and knowing all the cost and operation of such a thing, and also what's the other benefits comparing to other technologies, and also for the landfill. I think this could be a good proposal.
Okay, and
yes, thank you.
Something else related also to this issue, and we have received many of the quotations from the big giant Chinese companies working in the waste to energy, but unfortunately their prices are or became very close to the prices that's quoted by the US or Canada or even Europe. I don't know why.
Yeah, well, yeah. So I think one of the most important thing is the cooperation should goes between countries of China and Egypt regarding the One Belt, One Road. This will could help Egypt into this cooperation that could support the country getting the infrastructure, because it's I think that China has a very means to share the technology and to Africa, and regarding the finance, which is very important, since the institution from US and China could support also on the benefits for your country. And this is what we cannot discuss tomorrow regarding solution for the finance to the PPP law. And also I want to add that our university, Columbia, has advised the UN regarding the framework of the PPP, the PPP law, and Professor Burtsalas, who gonna present tomorrow. We will highlight it, and we're gonna discuss about this option.
So based on our BBB concept in Egypt, or
we can also, yeah, for general for countries to implement such a PPP, and I think the report will be available. I'm gonna share it with you as soon as the report will be issued. It's gonna be in different language, English, Arabic, and also French. Yeah, and we're gonna share it with you. We've been working on that. We provide a lot of comments, and I think he's gonna be, the documents will be issued soon. So I think we'll be very glad to share it with you. But tomorrow we will have time to discuss about this option, about it.
Okay, that's
yeah.
Okay, thank you.
Yeah, absolutely. You're welcome. And also one of the aspects of this training is, as Professor Mohi says, that we will discuss about brainstorm, how to be very effective, and how we could support the government of Egypt, Morocco, and also Tunisia to focus on solutions. We bring all together scientific, academic, engineers, public policies, and also industries to work on solutions. We need to focus on solutions. I'm sure there is a lot of challenges, but I'm sure this is the right way to do, and we need to act now, because unfortunately the climate change will hit us all together. So we need all together to collaborate, because if we don't collaborate, I don't think we're gonna achieve in any point to mitigate climate change.
Okay, thank you.
You're welcome. You're welcome. So if anybody wants to ask a question, don't be afraid. Just share it. If not, you can send us emails, and also we're gonna share with you all the materials, and you can prepare your questions. If you have any other reflections that come up maybe later on, there is no worries about that. We can receive your question later on, and we can respond. So I think if anybody here wants to ask question, I think we could close today's training, and I invite you eventually tomorrow to attend the next the workshop, starting the same time. I'm gonna wake up early. It's 4 a.m. in the morning. There's no worry. I am very excited. I love this my very passion, but there is no problem. We did fine. So yeah, and also I think tomorrow Morocco is playing. I hope success in the World Cup, and I think it's going to be very good that Morocco passed to the next phase.
Hello, Mr. Reda, we should close the.
Yes, thank you.
Yeah,
thank you.
Your thanks. Thanks you very much. Thank you very much. I know your time is very early morning. Thank you very much. You organize and host and ladies and gentlemen, very honored and very glad to have this training today. We try to provide some useful experiments. Maybe it's only depend on our understanding. We try to understand, provide. So this is a first the start point. I hope after then, just mention Mr. Reda said he will close your contact information, and we will provide our contact information so we can know each other and keep contact. From today, we hope to have more and more cooperation. And according to experiments of China, I want to say, in China, exactly we from the very low economy level, for example, in 30 years ago or in 20 years ago, near the same your country, maybe the 10 years near the same your country, but since 1990s in China, we started the installation with energies. Exactly these directions. We faced the challenge of the cost and technology and the policy or some things. We overcome. So we have experiments. We can provide some experiment. We can shorten. Maybe we want to shorten the time. Shorten the cost if possible. So just to say, Mr. Reda, I hope to meet you in tomorrow. I believe, I'm confident that tomorrow presentation will be very excellent and very useful for all of you. So thank you very much.
Yeah, sure thing.
I hope
you so
you
much.
enjoy our training workshop. Thank you. So
yeah,
Reda, you're close. Okay.
Yeah, thank you so much. Yeah. Okay. See you tomorrow.
iPhone, yeah, from Everbright.
Thank you, everybody. See you tomorrow.
Thank you.
Okay.
See you.
Bye bye.
Yes, thank you.
Thank you. See you
Goodbye.
tomorrow. See you
And
tomorrow.
see you tomorrow.
See you tomorrow. Reda, you can sleep again. See you.
Yeah, thanks.
Thank you.
Bye-bye.
Bye.
Thank you, Dr. Reda. Thank you, Dr. Lee.
Không làm gì cả.